But it's
even
not so.
night has become quite intolerable. No, they are ready to start, right?
No, this is 10:50. Yes, it is almost time.
No, but it's already past 10:48.
Hello. Arvind sir, can you hear me?
Yes, I'm able to hear you, and you are not hearing me.
Yeah. Now only I started, and the speaker I have not initiated.
You are in the idiom.
This is the speaker.
Hello.
So I don't have any earbuds. This.
Hello.
Yeah, a man of advanced technology.
Yeah.
Yeah, he is 50 years ahead of us.
Yes.
And
actually,
yeah. I request Professor Krishnamurthy sir, please occupy the chair and conduct Professor G. Sankarnarayan Symposium lectures.
Okay.
Hello.
Yeah, I am able to hear you. I am able to hear you.
Sir, I request Professor Krishnamurthy sir, please occupy
I'm
the chair
here.
and conduct the.
Yeah. Okay. Shall I proceed? Shall I straight proceed?
Yeah, you proceed, sir.
சார் வாங்க. என்ன எங்க இதுல ஆன்லைன்ல வாங்க. ஐயோ ஆண்டவா, அது நான் உங்களுக்கு இப்ப சொல்றேன். நானு அந்த லிங்க் அனுப்புறேன். ரைட்டா? ரைட். ஆமா, ஜூம் மீட்டிங் நான் அனுப்புறேன் உங்களுக்கு லிங்க். உங்களுக்கு டாக் இப்போ அறிவறிங்க இந்த ஃபர்ஸ்ட் இன்னும் ஆரம்பிக்கல, அதனால இப்ப உங்களுக்கு அனுப்புறேன் லிங்க். என்ன பண்றாங்க அவங்க லிங்க் அவங்க நான் சொன்னதுக்கு அப்புறம் எல்லா ஸ்பீக்கருக்கெல்லாம் அனுப்புங்கன்னு சொல்லியிருந்தேன். அவங்க இப்ப மாடர்ன் பண்ணது இப்ப யார் அனுப்புவாங்கன்னு சொல்லிட்டு பேசாம விட்டாங்க போது. நான் அனுப்புறேன் சார், இப்போ நான் அனுப்புறேன். ஓகே.
Why Uday Bhaskaran's lecture is scheduled, right? Oh, I thought there are only 2 speakers.
Oh, sir,
he is ready, sir.
About that, we can go up to 12:30 or 12:35 because see they are having another session at 12:30.
Yes.
Okay, we'll go up to 12:30. But then unfortunately time will be too limited.
Yeah.
The second speaker, yourself or USB?
Uday Bhaskaran.
Shall we start, sir?
I think
I am ready. Time is running out.
Time is running out. Okay, you can start. Uday Bhaskaran will join.
Yeah, but see, the organizers asked me to wait for some time. I don't know what for.
Oh, maybe people are going from other halls, sir.
Yeah, because there are only hardly how many participants now? Only 7, including
Speakers.
yeah, including speakers and the so-called chairperson.
Because now the others, they have no search for it and they have to come for this hall numbers.
Sir, many of them do not know the link for joining this particular
So they
session.
are all provided, I believe.
Yeah, long time back. When the plenary section was organized, we didn't know that I have to join Hall A.
Oh.
When I asked them, they said Hall A. Now people are sitting still in Hall A, I think.
No, possibly yes.
Initially, they didn't inform about the plenary section.
No.
What is the link?
No.
Then only they informed. When I asked, they informed me to join the Hall A.
Very strange.
See, they are not mentioned where is that inauguration will take place.
Yeah.
No, I think that was in Hall A where BLSP was giving his plenary talk.
Right. பாத்துட்டீங்களா? Hearing. ஆமா. Yes, you are there. Okay. Thank you, sir. Thank
Sir,
you.
please, Professor, please note that the time is 10:50 to 11:25 into 3. Why?
Yeah?
I don't understand.
No, only 35 minutes for each speaker.
And into 3 minutes, it goes beyond 1.5 hours. It's nearly 1.5 hours.
Yeah. Tangaraj will be speaking up to 12 o'clock. And then, or Uday Bhaskar.
Yeah.
Tangaraj.
Yeah, it is separate, right?
But then, see, we do not have, no, we lack 5 minutes then.
I will cut down, sir.
Good morning, Krishnamurthy sir.
Yeah, I'm here.
Good morning. Arivaranjan, good morning.
Good morning, sir. Good morning, Professor. It is very honorable to see you on screen, but you are still not on the screen. Why?
I don't know how to.
Please switch on the video. Click the video icon. Yeah, I was able to see your calendar.
Yeah. Player calendar is there.
That is hanging on your wall.
Yeah.
Slightly lower your.
Also, you can see Nataraja, not Nataraja.
Slightly lower your screen, sir.
Yes, sir.
Frozen. Sir, please lower your screen. So we'll have an opportunity to see you.
I don't know how to lower it.
Just tilt your screen. All right, now you got it.
Yeah.
Uday Bhaskar.
Sir.
Namaste.
Beautiful.
Namaste, sir. Angaraj, your virtual background is very beautiful.
He is far away from the sea. His residence is far away from the sea. So he wants to be very close to sea always. So he keeps ocean background.
He is Alagadal Nayagan.
Sir, அலைகள் ஓய்வதில்லை சார். அலைகள் ஓய்வதில்லை. Professor VTs அலைகள் ஓய்வதில்லை.
Sir, can we start this session, please?
Yeah, we should start now. It's getting too late. Who is the coordinator?
So Dr. Ari Visakan
the
is
speaker.
already
I
there,
am the
so you
speaker.
can share this screen and start the presentation.
Okay, so shall I just start reading out the speakers and then proceed? Hello?
Sir, Chairperson Krishnamurthy can introduce the speaker, sir, and speaker can start.
Yeah, I'm going to start the session. Okay. Good morning to all of you. We start the session, but at the very outset, I would like to share with you the sad demise of two great probabilists and mathematicians, Professor Pakshirajan first, and then that is on the 24th of January.
Yes, sir. Sir,
Pardon me?
Professor Krishna. Sir,
No.
what? Any doubt, sir?
Professor Pakshirajan passed away on the 24th of January this year. And later,
Yes, sir.
Professor D.
You are the chair for the session, sir.
Yeah, I am just starting it. I'm just telling because, see, Professor Pakshirajan was with Osmania University straight from USA after his doctoral program.
He is giving homage.
And then Professor D. Kannan, they were really very eminent probabilists. They contributed tremendously to the area of, several areas. Professor Pakshirajan was quite well known for his contributions to limit theorems, law of iterated logarithms, and several other things. And Professor Kannan, did a lot in stochastic calculus related things, insurance and whatnot, several areas. So it was indeed a very great loss for all of us. Now we start the session. I particularly mentioned about Professor Pakshirajan because one, he is very eminent as a probabilist. Second thing is he was associated with Osmania University when he returned after his PhD program from Oregon. He straight joined Osmania University, wherefrom he joined Mysore University. Okay, we start this session. There are three speakers. Professor Arivaringan, the first speaker, followed by Professor Udayabhaskaran, followed by Professor Tangaraj. Professor Arivaringan has done extensive work, especially in inventory. In fact, his papers were the motivation for me to work in this area. 1995 in a classical inventory, and subsequently in the early 2000s, first decade of 2000, I started working in queuing inventory, all because I just saw papers by Professor Arivaringan. He has done extensive work in this area. He was, after his retirement from Mvk University, as professor of statistics in the Department of School of Mathematical Sciences. He joined there as a CSIR Emeritus Fellow. Subsequently, he was selected for the UGC Emeritus Fellowship. And then he worked at MS University, Tirunelveli. And still he is continuing there. His contribution to this area is quite extensive. First, I invite him for the talk. Okay, Professor Arivaringan.
Thank you, sir. Thank you very much for your nice introduction about me. I thank the organizers, particularly Professor Jayashri, Professor Balakrishna, Professor Bhattacharya, Professor Ajay Reddy, and others. I am very much honored for being invited to talk in Professor GS endowment lecture. I was a proud student of Professor GS. Professor Krishnamurthy talked about Pakshirajan and Kannan. Both professors, Professor Pakshirajan and Kannan, visited MKU while I am on service on my invitation, and for also that I feel very honored. Good morning to all professors and scholars, online and offline. I will start sharing my screen. Professor Krishnamurthy Saru, I got a, I don't know whether this particular presentation software works here. I will try to do that. If anything goes wrong, I will come back to my. So are you able to see my presentation, sir?
No, not yet.
Share screen.
I think share screen and then there is something to be done. You know it very well.
Sir,
Yes, sir,
you
but,
please press on the share screen option and then select the files.
No, I am.
Now it's visible.
Yes. My talk is product inventory system that works in a random environment, and I am going to consider two types of arrivals, and their arrivals are modeled through MVK, Markov arrival process. This work is joint work with my students. Now they are my colleagues at MKU. Now Professor Sopmar is my colleague at MKU. Karthik is in Coimbatore, PhD of Technology. Myself at MSU, I am the presenter. My talk will cover briefly on 6 items: introduction, the model, algorithmic solution, system performance measures, cost analysis, numerical illustrations. It went somewhere. Why? I'm sorry. I clicked. I should have clicked here. Introduction. The subject area is stochastic modeling because I'm talking to a general audience. But at the time of preparation, I want to inform the audience that my area is stochastic modeling. Sub area is modeling of random inventory systems. I'm going to apply the tools of applied probability and stochastic process. Before I go proceed, I want to say a few words about the milestones in the earlier 20th century. Harris in 1913 developed a Mvk formula, which is also known as the square root formula, square root of 2ak by h. And this particular format is used for a long time in textbooks and many research books. The work by Rao and Collins in 1958, this paved the way for modeling of inventory systems of stochastic methods. The last quarter of 20th century had a tremendous growth in modeling of inventory systems. Queen theory and inventory systems are closely related, but inventory theory gives a controlling of the maintaining the stock. So the major decisions to be taken is when to order, how much to order. So that is at what time you have to place order and how much you have to order. That's the two important things. So another important aspect I have to talk about is the inventory specific system events, that is demand times, time at which reorder is placed, time at which it is received, etc. may be monitored periodically at specific time points. In the 20th century, people considered the inventory only at the beginning of day, at the beginning of week, or so on. So a long time period. But at the end of 20th century, they started considering the continuously monitoring the system. That is due to advances in stochastic process. That is, they use the various technology with the methodology available through probability and the stochastic process. They were able to manage this. And now, due to various sensors available on production machines and inventory maintenance places, so they consider small time slots. Within that time slot, a demand occur or a item is delivered or a supply is sorted or so on. So they do not consider continuously. There is a small slot. Within a small slot, two or three things can happen. Now, in this case, in this presentation, I am going to consider continuous review case only. So, particularly, I am going to consider a production in unitary systems. What is the necessity for this? So usually items are replenished by buying a lot of items from another source, procuring or producing and so on. Another company will be producing and you procure. Now, recently, the producing in factory as and when this very recent development in industry. So this is recently being considered the 21st century. Only few articles in the literature considered. The second case, the necessity is this. The technology is changing very fast. So you can't have one particular item produced and stocked forever. But whenever there's a technology changes, the parts will change. The configuration, specification changes. So that's why to meet the specification of products, they have to produce as and when they require. They can't place an order, wait for it. To safeguard trademark rights, many companies nowadays, they produce their own in-factory production rights and they want to keep it to themselves. Okay. This is the literature. I'm going to give only few. Particularly the Mvk and Mvk is a major contributor. And I want to mention here, Professor Krishnamurthy with Professor Narayan have done some work, sufficient work, but I will give you only one paper here. But I want to mention that he has done some work here. And Swakumar has also done some work on that with me. Anybody mistake? I'm sorry, it came out of it. So the assumptions, the model assumptions are here.
No, Professor Rajavingan, the screen is not still visible. I mean, presentation is not...
I went out of it and there's a problem.
Oh, I see.
Rejoin. I came out of it. That's the problem. Is it okay, sir?
Yeah, it is okay.
This is a new software I downloaded. That's why it came out. So I can say SS inventory system, and actually here I do not mean the traditional way. That is usually at the time when the inventory level comes to smallest, you place an order and you place an order for capital S minus small s of items, and it will receive after some lead time, that whatever you receive that you retain. But here in this context, the idea is I will start the production at time when the inventory comes to smallest, it will be produced one by one. The stock is represented by producing items by machine one by one, and we'll stop that production machine when the inventory level reaches capital S. So the idea is not producing the whole. So it is possible in some cases. For instance, producing nuts and bolts, they can produce in a large quantity, but producing a particular chip or some items connected to mobile or car, they have to produce one by one. The production time is stochastic. The production is started at a prefix S and stopped when stock size HS capital S. Production machine may fail after some random time. The failed machine can be repaired. The repair time is stochastic. Yes. So the model assumption continues. I am going to say that this customers belong to two types, as I said earlier in my talk. That is, in the title itself, it's a two types of customers. Their types differ in two ways. When they, what is the preference they give in receiving the demand items? Type 2 customers' demands is always met if items are available. Please note that the customers are distinguished the way they are served. Actually, the stock keeper knew a way to distinguish two types. So type 2 customers, they are type 1 customers. I will give an example for that. Type 2 customers demand is always met if items are available, otherwise they are lost. Type 1 customers demand is immediately met if the stock level is above S. There is a stock. If there is a stock, it is immediately met. Suppose the stock level is between small 1 and small s, provided the production is on. Please note that at the time yes, we start the production machine. Sometimes it may fail. So the type 1 customers will not get the demand if the machine is off or it failed. Moreover, if there is no stock in item, the customer, type 1 customer, are not served. They will be sent to an orbit of infinite size. From orbit, they retry. So I will briefly explain through an example, or at least a graphical description is here. This is the invertible S, S minus 2. There is, it may go from S to S minus 1 or from S minus to capital S. So when the production machine is on, and if there is a demand, the unit will go from S to S minus 1 and down S plus 1, S. At the time the machine is started, and hereafter the inverter goes down or goes up. When the demand is there, it goes down. Otherwise, if the production is completed one item, it goes up. So during the first half, the production may be on or not started or under repair. Here, the production is started, but it may be under repair. So type 2 customers are always met until there is no item. Type 1 customer, their items are served only in the first half of the first portion of the unit level, and the second portion, they will receive that quantity only when the production machines on, not on off. Where the stock is 0, they go to orbit. No,
otherwise, what will happen? Professor, are you with me? I have one question.
Yes, sir.
See, when the production is off, type 1 customers, do they have an infinite queue in front of the, no? Can they wait, or they have to go to orbit? That is not.
Yeah, yes, sir. Yes, sir. They will go to orbit. And it's like,
that is not mentioned here. Actually,
yeah, but yeah, that should be the case. Otherwise, the type 1 customers, either they are given, they are served, or they are sent to orbit. That's the thing. Only type 2 customer, they are served or they are lost.
Yeah.
So type 1 customer, if there is machine is not, suppose machine is under repair, they do that any item to, they are not going to be served. So they go to orbit. So I should add this, right? modeling, we are taking care of that. Here, this is not mentioned here. So can I proceed, sir?
Okay.
So some possible cases, and just to give you an example, but it's not covering all the aspects of my problem or model. In the case of automobile spare parts shop, local mechanic arrives and demands an item. He may want it immediately. The customers from distant places may place or register, or in other words, they may wait or they go to the orbit. When they wait, we take it as an orbit. So they may place an item, register, and they collect the item if available or at later time point. Another case is a medical shop of patients of chronic illness or who are in need of special drugs. Some would want them immediately, others prefer to wait for registering the demands. So they can give some more examples, but I have only two cases here to search for that. It gives an idea about our model.
There is no service time associated with that. It's
Sir?
not with the no, it is not with the positive service time. It is only just inventory.
No, these two cases gives only few aspects of my model.
Oh.
In some cases, there could be a production. That example is not given here.
No, service
Because-
time. I'm asking about this service time. Is it a negligible or a positive?
Sir, I will come back to sir. I
Okay.
complete. Right.
Okay.
I think I should go to that first. Yeah. Machine lifetime is exponential, repeating exponential, intro type in 2 successive trials. Production time is PKG distribution. Okay. Production
No,
time.
I'm asking about the service time.
No, there is no system, sir. Only
Okay, okay.
production.
Okay, now it is okay.
So I have drawn a picture for inventory from 0 to 5, and this the inventory is going down or going up when the product is there, but there are machine items under repair, or when the item is nil, that is stock is 0. It has come to 0 here. A demand of first, second time, demand of 2, they join the orbit. I'm sorry, I made a mistake. Not 2, 1. Demand of type 1 here. I made a mistake in typing here. Right. This would be D1, D1. So stochastic process, I think that the time is 11. I need at least 10 minutes, sir.
And yeah, I have 10 minutes only.
Okay. Machine lifetime is exponential. Repair time is exponential. Intro type with 2 successive iterations is exponential theta. So parameters are different, except that they are independent. The production time has a PKG distribution. Many of us here, there are only I don't know how many people are here. Only so most of you know about phase type, and demand types is denoted by D0, D1, D2. That is not D0. Actually,
Is it a Markov array process? You earlier stated Markov array process for 2 distinct types. Or is it a Markovian?
Markov arrival process of 2 types. That's all, sir.
Yeah, but you have considered independent Markovian array processes.
No,
2
sir.
independent, not a
No,
Markovian.
No, there is only one Markov arrival process. That's all.
That means it is Markovian.
Sir,
2 types are there.
2 types are there. They are occurring according to the Markov arrival process. I choose the D1, D2 matrix in such a way that they are correlated, may be correlated.
Yeah, that's right.
Wait, I will come to that, sir. I think those things can be clarified now itself. I think the work arrival process, with no arrival, one arrival, and actually here we made a type 1 arrival, type 2 arrival. We are choosing this particular map matrices. We can make a positive correlation, negative correlation among them, sir. And actually, I'm going to explain here about the Markovian processes. I will go to my red matrix. So the model formulation is 1, 2, 3, 4, 5 component matrices, 5 component vector. This process is the number of customers in the orbit, inventory level, mission status, and J1 is the phase of the production process, the phase of the arrival process.
Yeah, there are two distinct arrival processes, you said. Two distinct arrival processes. Two distinct.
Yes, sir. Yes, sir. Yes, sir.
But then, according to this, there is only one arrival that you are considering, J2.
One arrival, there are two types.
So it is Markovian. That's why I said Markovian arrival process.
Then I have to check it, sir. Maybe,
yeah. Otherwise, what will happen is that there is a sort of a confusion appearing. See, Markov means even the two arrival process, you are just marking them as a type 1 or type 2.
Yes, sir. Type 1, yes,
D2
sir.
is the type 2, D1 is the type 1. Okay.
But that D1 is occurring according to a process red matrix D0 and D1. That is, I am going to explain D1 here. D0 will come.
I have not seen the D2, effect of D2. D2 is written here.
Yes, sir. We will take care of that point, sir. Maybe I didn't explain correctly the process.
Yeah.
Actually, this is the expression for D0, but we are going to consider what about the demand types map? No arrival, type 1, type 2, sir.
Yeah, that
D0,
I noticed, but I did not see the effect of D2, of course, that appears in the infinitesimal generator. But this sort of thing we generally call Markovian rather than just Markovian, because otherwise you have to indicate them with the two different maps, say D01, D11, D02, D12.
So that will be inside, sir. You say that D0, D01, D02? No, sir.
I'm telling about that. It is Markovian. Or if the effect will not be clear there. And we'll discuss it later. I will talk to you.
Okay, sir.
Otherwise, the time will be wasted on it.
Yeah, sir.
I'll talk to you.
Okay, sir. The idea is the time is 11:31.
That is the problem.
Now, I think we have to the red matrix. I give you some console to get the stability condition. I have given some explanation here, but now that is with some condition. That is, to get the condition, I need a vector of the say in univariate Ewing theory models, we look for a solution phi n equal to pi 0 rho n. Similarly, here tridiagonal matrix here. So we look for a solution phi n equal to pi 0 Rn. So this is the idea. Here we need rho less than 1. Here spectral radius less than 1. And of course, this is very difficult to obtain. Newts have given one important result. That is this phi 0 pi A0E pi D, where pi is the stationary vector of this. Right, sir? Now, with this condition, we give a theorem. The theorem says, the theorem I will show here. The solution, the limiting probability distribution is given by this, and substituting in the matrix that is here. Second equation, we get this equation. So it's a solution of the quadratic equation in matrix form. And finally, we give a condition to obtain R using a recursive method. This is a recursive method we use here, and obtain R0, compute R1. Put here, get R2. Put R2 here, get R3. So it's similar to your univariate recursive formula. So we define the average unit level, expected production startup, expected repair times, and expected number of demands, and overall rate of array trials, and so on. Then finally, we construct a total expected cost rate using this, where CS is the production startup cost, CH is the unit carrying cost. And with this cost, what we are doing is we are given an analytical, not analytical, algorithmic result we have shown. That is the convexity of the total cost as a function of capital and small s is not given, but simple numerical search procedure to get the active values of S and S scheduled. To get an idea for a particular set of parameters, we are able to show that the total cost is convex, and for selected exponential, L long hyper exponential, and for renewal process, and so on, we have taken, so we have computed some numerical values. Of course, the two tables are shown here. When the lambda 1 is increasing, the total cost is also increasing corresponding to the particular demand process, particular production time. And these blue colors are showing that they are increasing, yellow color, and so on. So we are able to get more results, and minimum result, I am able to consult only few in the slide here. So the inference from the tables, the optimal cost rate increases as each of lambda 1, lambda 2, gamma, and mu increases, and decreases as each of beta and theta decreases, and so on. Time is 11:36. So though we have said is the effect of many parameters and costs on optimal parameter quantities, not only the total cost. I'm going to give, we're able to give the first top quantity is capital S, small s, capital S, small s. So the bottom quantity is total cost rate, that is cost, total cost, expected cost per unit time. Here the optimal value of small capital S, small s. So we are able to compute this, and we are able to see certain patterns in the small s or capital S according to the change of parameters. Sir,
Okay.
with this I close.
Professor, it was a really wonderful model. I really enjoyed it. But there are some minor modifications that are needed.
Maybe I am not able to give that very clearly, sir.
Yeah,
that
I
has been
talked to you
taken care
about
of.
it. Yeah, and incidentally, Professor Adivingen just edited a special issue of Annals of Operation Search probably sometime in 2015 or so.
Yes, yes, sir.
Yeah. In this connection, I have my paper with Vishwanath in EJOR also, production inventory.
Yes, sir.
With the positive service time. Okay. So we pass on to Professor Udaya Bhaskaran. he was with the collegiate education. No, he was a professor in government services of Tamil Nadu, and then he was appointed director of collegiate education. He has his PhD from IIT under the guidance of Professor S.K. Srinivasan, a very well-known provost again. And incidentally, Professor Advitingen also had his doctoral degree from the same institution, IIT Chennai, under the guidance of the student of Professor Srinivasan, Professor Kalpaga.
Yes, sir.
Professor Devaskaran, are you ready? Professor Devaskaran? Professor Tangaraj, what happened to him?
So meanwhile, you can ask Professor Tangaraj to talk, sir.
Okay, Professor Tangaraj will then present. The last speaker will be Professor Devaskaran. He is not seen now. Professor Tangaraj, can you take over? Hello?
Professor AK is addressed to Tangaraj.
Yeah, I'm trying to, should I, no, he's speaking to, I think, to Devaskaran. Hello, Professor Tangaraj, can you start? Or Devaskaran will... No.
Professor Tangaraj is inviting Professor Devaskaran.
Anyway, it's a quite interesting model that we have developed. I'm really happy about it.
Okay, sir.
But that, in the tables, you have not mentioned anything about D2. That was what I did not see anything about the D2, that matrix D2, in the numerical illustrations.
Just to, because maybe it is cut off on the edge of the screen.
Oh, possibly,
I'm trying to excuse. That is the problem with the presentation slides. We use a software from article to presentation. So some of the portion of the other side maybe excused.
Oh, yeah. Tangaraj?
Tangaraj, sir?
Yeah.
What happened to Devaskaran?
I don't know. Because he joined.
He's not now seen. See, we have to start. Otherwise, you start the talk.
Sir?
You can start.
You can start.
Think போயிடுச்சா மறுபடியும் ஸ்டார்ட் பண்ணுங்க சரி நீங்க ஸ்டார்ட் பண்ணுங்க நான் வந்து நான் பிரசன்ட் பண்ணிட்டு இருக்கேன் அதுக்குள்ளார பட்டா ரைட் ஓகே ரைட்
So you can start.
Is it visible, sir?
Okay, it is visible. Let me just briefly introduce you, though most of the most in the audience are quite familiar with you. Professor Tangaraj, well, he again has his PhD with Professor G. Shankaranarayanan, our great guru, in whose memory, or rather, it is an endowment under his name, Professor G. Shankaranarayanan Endowment Lecture. So he was a great inspirer for all of us. And then we did whatever we could. Professor Tangaraj, well, he was Professor Shankaranarayan's right hand. He worked extensively in several areas. And his depth of reading and then the depth of knowledge, that I really envy. He has plenty of publications. He held several positions in addition to the academic thing, controlling the whole university as controller of examinations, registrar in charge, and whatnot. He was formerly director of the Ramanujan Institute of Mathematics, Advanced Study in Mathematics for the University of Madras. Well, his contribution to random polynomials is also really marvelous. He brought in some discipline, a lot of discipline in the examination section, or probably in the whole of the Madras University, which improved its functioning tremendously. So, in fact, I have no word to explain, or rather to tell you about Professor Tangaraj's contribution to several things. He's an excellent teacher also. Very good presentation. He does not require a mic. Probably he can speak from Chennai without any of these things, and we'll be able to still hear him. Okay, Professor Tangaraj. So really great to have you as a speaker.
Thank you very much, sir, for your nice introduction. At the outset, I thank the organizers and also given me an opportunity to present my small contribution in the theory of random polynomials. And here, instead of giving my contribution, and this is a topic how it came to India. First of all, it is traveled from UK to India. Okay, right now, before starting this, I thank all the members of the organizing committee of this conference in a great measure. And now, straight away, I go into the topic of random polynomials. A cursor view. There may be some spelling mistake in the schedule pointed out by Professor Arivaringan. Okay, thank you. Now, what is random polynomial? Where it comes? How motivated to study? We know quadratic equation and then solution. How to find out the solution or find out the roots for quadratic equation and other things. When the coefficients are random, how it is going to come in the natural way. Now, look at this motivation from medicine. It is a mapping of brain. Mapping of brain forms the random polynomial structure. And also, and here this is from the geography, Brownian sheet in RN. And here also we come across polynomials with the coefficients are random. And especially from statistical physics, the positions of a quantized vortices in 2D rotating ideal Bose gas can be mapped to the zeros of random polynomial depicting the atomic state. Therefore, the zeros of polynomials are nothing but atomic states in statistical physics. Now you know that what is the importance of studying zeros of random polynomials. Zeros or random polynomials are popping up in many areas of physics as peak points of signals, vacui in compactification of M theory on LITO manifold with the flux, extremal black holes, weak points of galaxy distribution, etc. Therefore, when I look at this problems arising in a natural way in a different branches of study, one has to dwell into the problems which are coming in a natural way. Algebraic geometers are interested in zeros of holomorphic sections of any positive holomorphic line bundles over any Kähler manifold. Therefore, this topic, random polynomial, itself considered to be a topic in random algebraic geometry. This is a random function f of t, where x of xk is a random function and fk is some algebraic quantity. So the algebraic quantity multiplied by the coefficients are random. Therefore, this summation is called a random function. The value of the random function at each point t is a random variable. So if we take xk of t equal to t power k, then it's a random algebraic polynomial. So if we take sin kt, cos kt, that ak sin kt plus bk sin kt, then becomes a random trigonometric polynomials. Now, first case, where that the zeros are in the real line, it is going to seen around +1 and -1 as far as random algebraic polynomial are considered, with specific distributions for random coefficients. Now, what is a cat polynomial? We take the polynomial function which are already given, and where the coefficients are Gaussian, we call it named cat polynomial. And the xk's are normal random variables to mean Vk and variance sigma k. So NFR, number of real zeros of random polynomial with the degree n, expectation of a number of real zeros of random polynomials. Already I indicated that what is these zeros are nothing but atomic states when we study the statistical physics. And here is an expectation, and because the coefficients are random, naturally you have number of real roots are also random, and the estimation of these quantities will be the interest of people started from Littlewood, Harvard, like this. I will give that brief outline of how the problems came and then how they started studying this random polynomial in England. And of course, the variance of the number of real zeros. And my work and the contribution on the variance of the real numbers. And in fact, there are only 3 papers available on the variance, and the 2 papers are mine. One is a Russian lady. Motivation from the existing results. It is known that the real Gaussian random polynomials whose coefficients are independent, identically distributed normal random variables, they have zeros concentrated on +1 and -1. How? That we will show it, how it comes. Then zeros of complex Gaussian random polynomials, and the coefficients are complex random complex Gaussian random variable, then the real zeros are going to concentrate on the unit circle in the complex domain. So in the real line, it is concentrating on -1 and +1, but in the complex plane, it is going to concentrate on the unit disk. So the problem becomes more and more interesting. Further, we orthonormalize the polynomial on the boundary of any simply connected domain in the complex plane. Zeros associated with the random polynomial concentrate on the boundary of any region. So it started with the +1 -1, and then concentrated on the unit circle, now concentrated on the boundary. Now things are becoming more and more, and then we have to dwell what are the problems arising in these random polynomial cases. Now this situation triggers a question whether there are random polynomials whose zeros are uniform on the complex plane. Once we identified the complex plane that roots are around the unit circle, in another point, and then it is the boundary of the some connected region. And now the question is whether the zeros are uniformly on the complex plane or not. This question raises, surprisingly, the answer is positive with a suitable choice of inner product and metric. So it is possible. It is possible to have all the zeros are uniformly distributed on the complex plane. And these observations motivate us to study, summarize, and explore the results as well as new avenues for further investigation in the theory of random polynomials. And not only that, and recently when I presented such type of material in Atlanta, people were surprised how these results are, appearing in mobile phones. When I was explaining this, when the waves are independent and it will reach your ear. When the waves are dependent, then that waves will collide with each other. Then you won't get that message very clearly. You will get a noise disturbance. So this is all the implications or observations behind the study of random polynomials. Sometimes it may become very hard nut to crack, definitely, because I spent 2 years to solve a single problem. Therefore, there are more hot nuts. Therefore, it's not advisable to delve into that. This is the problems and random polynomials. You have to do it in a very leisure manner. Kind of this talk is because the number of real zeros are random variable, exact evaluation will become very difficult. If the exact evaluation is not possible, what about the lower bound? What about the upper bound? This is what we want to study. And average number of real roots with the moments condition on the random coefficients. Maximum and minimum of number of real roots of random algebraic curves. Variance of the number of real roots with the moments conditions on the coefficients. Okay. One may consult a book by Burjaraden and Sarandam for historical developments, and Ferrament is in another book. And this is the first time that these methods are appearing in a book form. In the Ferrament book, he has obtained a number of sharp crossings, maxima below the level, and excellence measure to compensate the absence of vertical image. These are all some of the developments that you can see it in this recent book by Ferrament. Of course, it is 1998. At first, consider, and let us start with a simple problem. Ax square plus bx plus c equal to 0, where a, b, c are IID uniform random variable. The probability of real zeros of this equation is an exercise in Carlin's book. You can see that 1975, page number 36, problem 1, first problem. What is that? As an exercise, one can attempt to this. It is evaluated using the shadow method as follows. Now, the probability of real zeros is PR, probability of b square greater than or equal to AC, 1 minus probability of b square less than 4AC. This is nothing but triple integral over dc dv dA b square less than 4AC, right? And then after evaluating this, you will get 5 plus 3 log 4 by 36. So this is the probability of real zeros of the quadratic equation whose coefficients follow uniform normal distribution. Of course, this answer he has given, but the method he has not given. Method we try to find out this. Okay, as a generalization, we'll go for -1 to +1. The uniform random variable is going from 0 to 1. Now we take the -1 to 1. The probability of real zeros of this quadratic equation is 41 by 72 plus log 2 by 12. Right. Now, real roots and the complex roots of the quadratic equation, there is a PhD thesis, 1955. Here the equation is x square plus psi1x and psi2x equal to 0, where psi1, psi2 for general bivariate normal distribution with the means mu1, mu2, and standard deviation sigma 1, sigma 2, constant correlation rho of gamma density and a gamma density type. Okay. Right. Now the cubic equation as a generalization, consider the cubic equation and ax cube plus bx square plus cx plus d, where the ABCD are uniformly distributed from -1 to +1. Look at this. This simple problem has not evaluated so far. Now this is an open problem now. How to evaluate this 4 iterated integral over -1 to +1? Cross 4 times. So here this indicator function of delta greater than 0 is this part. So this is a very challenging integration, and one has to find out the solution, what is its value. So even for a quadratic equation, that means a polynomial of a degree 3 whose coefficients are uniformly distributed random variables has no solution. It's a challenge.
But Professor Thangaraj, what
Yes.
about the 0 plus 1 case? That is
0
what?
plus 1?
When uniform, IID uniform in 0 plus 1 rather than -1 plus 1.
No, in either case, is a problem is open.
Oh, I see. Whether it is 0 plus 1 or -1 plus 1.
Yeah.
Oh.
Yeah. Still the problem is open.
Oh, that's interesting.
Equation, there is no solution.
looks so simple, but so complex.
But it is very difficult to evaluate. Okay.
Oh, very good.
And then for random cubic equation, has discussed the cubic equation of this type. Now look at this. This is second. X square term is missing here. So because here again it is his thesis, right? Cubic equation. The psi1, psi2 are random variables. The well-known result in the theory of equation gives the following information about the zeros or roots of this equation. Look at this. If psi2 square by 4 plus psi1 cube by 27 greater than 0, then there are exactly 1 real root and 2 conjugate imaginary roots. If this is equal to 0, then there are exactly 1 real root and 2 conjugate imaginary roots. When it is less than 0, then there are 3 distinct real roots. So this is observation in his thesis. These 3 conditions define a disjoint partition of omega into 3 events, D, S, and K. respectively. And then depending upon that, you will have to find out the solution, right? Then the density defined HUB over DK have been calculated in the thesis. I will call you back. I am in a meeting. When the degree is n, we have to use calculus carefully as enunciated by Cox and Edelman, Postland. See, this Cox and then Rice, they independently they have evaluated for a degree n only because this exact evaluation is difficult, and therefore if exact evaluation is not available, as n goes to infinity, what happens is the study, and therefore given the formula, Rice formula, that is available in the literature. Now we make a modest attempt to review recent different developments. Now our journey starts in a rosy garden. How? Let us state a Cox counting formula. For this purpose, we state the known definition. Let f be AB2R be a C1 function. Then we may say that f is convenient if the following conditions are satisfied. F of A into f of B not equal to 0. If f of t equal to 0, then f dash of t not equal to 0. Then see, the problem started from 1637. Descartes recorded his famous rule of counting real roots of algebraic equation in his book Geometry. In 1829, see, look at this, after 200 years, Sturm gave a most precise result on the counting the number of roots of the equation, right? And then this introduction of random character in the equation has created a challenge, right? At first, varying, here also again comes a varying problem. Varings in 1782 and Sylvester in 1864 used probabilistic methods in random polynomials. It's a starting point. During 32, Black and Polya, Littlewood and Harford, 98, started the game of calculating the number of real roots of random polynomials in a very tricky way. Of course, when it go to the paper, you will find out how much mathematics is essential to find out or to study the number of real roots of random polynomials. But Cox in 1943 is the first person to give elegant and beautiful formula for finding the average number of real zeros of random algebraic polynomial with Gaussian coefficients. Now look at this. Let f be a convenient C1 function, then number of real roots is given by 1 by 2 epsilon a to b indicator function of f of t less than epsilon f dash of t dt. So this is he is catching the number of zeros using this integral equation in an integral. As in Cox, let us start with the direct delta function. We know what is it is. What is a when d0 of x is equal to infinity, when x is equal to 0, it is equal to 0 when x not equal to 0. And its approximation, x goes to 1 by 2 epsilon, indicator function of mod x is less than epsilon. Here, this gives an idea. In the earlier slide, I have shown that number of roots based on this catch. This is a good catch to start with studying the number of roots of the polynomial, which is by change of variable x to f of x gives, instead of x you put f of t, then you will get that desired formula. Look at this. Now this leads to that simple idea leads to the direct delta function f dash of t that is equal to n, which leads to Cox counting formula 1 by 2 epsilon, the indicator function. Okay, now this is a basic idea of how this Cox formula is formulated. But when you read the Cox paper, we cannot understand how he arrived at it. But after long probing into this, how he arrived at the immediately trigonometric integral, and based on this, how I'm going to I will show it. Now the expected number of real zeros of the polynomial. Now you take the expectation. N we have calculated as an integral. Now you have to take the expectation of the indicator function. Fine. What is the expectation of the indicator function? You know. Now let me take G is an indicator function defined by like this. Then the above formula can be written as expectation of this number of real zeros over the interval 0 to b is 1 by 2 epsilon. Expectation of G of function like this. Fine. Pimentel has remarked that a cascade set roughly, this does not require Gaussian assumption. F has a 0 and letting epsilon tends to multiplying by 1 by epsilon, then the expectation gives density of F at 0 is multiplied by the expectation of this, conditional expectation of this. For any Gaussian pair with the covariances A, B, C, the density X at is 1 by root A, and this expectation is square root of delta by A, where this is a discriminant, determinant AC minus B square. Now it resembles like B square minus 4AC in your Newton's formula. Thus, the density of X at 0, this conditional expectation, it all amounts to finally root delta by A. Now, suppose this vector f of t and f dash of t, that's a polynomial and its derivative, as covariant structure by taking KSC equal to expectation of f of s and f of t. Now, KTT, KST, KST, and then KST, which leads to very beautiful formula that root of delta divided by A is nothing but the square root of partial derivatives, or it's a logarithmic derivative of KST, the covariance function. Now here AT, then this KF, AT is nothing but summation T to raised to 2 power K, and then BT is nothing but A dash of T by 2, and CT is A double dash of T by 4 plus A dash of T by 4T. Now the characterized formula leads to this formulation. So this formula. Writing explicitly the above formula, now you can see that this is the formula given in the paper. How he arrived at it, it is using different technique I arrived at this. This expectation of the number of real groups is 4 by pi, 0 to 1. Now, minus into infinity, it is divided into 4 parts, 0 to 1, 1 to infinity, minus 1 to 0, and then minus infinity to minus 1. Therefore, it is 4 times. That's expectation because when you put x divided by 1 by x, you will get the same polynomial. Therefore, the whole in minus into infinity is divided by 4 times the expectation of this. That is a problem. Therefore, after integral, and it should satisfy all the real values from minus into plus infinity. So, how we are going to deal with this? That is a very beautifully and very thoughtfully diagonalized the integral. Then I will show you that after inputting all the A, B, C, you will get 1 minus hn square, things like this. And ultimately, as I was telling this, the usual, look at this previous slide, this 1 by t square, 1 by 1 minus t square, and this portion will go off. Now here, 1 by t square, 1 minus t square, tan h inverts by hyperbolic substitution. But here the mod t is less than 1. Okay. Here, when mod t greater than 1 hyperbolic distribution, you get cot h. So here, but the integral is going from minus to plus infinity. So what happens? By partial fraction method, you will get to log 1 plus t by 1 minus tc, where t is not equal to plus or minus 1, but it is not governing. So here, all the 3 values, it is only part of it you can evaluate this integral. But by trigonometric substitution, you will get logarithm 1 plus t. Again, t is not equal to plus or minus 1. Then, what is the value for 1 by 1 minus t square? And it should cover the value from minus into plus infinity. Now here, by Taylor series method, 1 by t square, when it is the Taylor series method also, you will get, again, it is a mod t less than 1, Taylor series method is valid. Again, it is not giving the value from minus into plus infinity. So, that logarithmic value only that logarithmic value which satisfies all the values from minus into plus infinity, and therefore this after evaluation it is given on terms of logarithm 2 by pi log n. So this is a very beautiful result given by CAT, and Rice also obtained the same asymptotic formula, asymptotic result. CAT and Rice, therefore the people call this a CAT-Rice formula. Now, you know, from the basic calculation, these are very basic, these two basic integrals we use in the first year BSc class. Now, this has got a lot of effort in our higher studies. Now, look at this 1 by pi minus into plus infinity sine zeta alpha by, it is nothing but the sine function of alpha, plus 1 or minus 1 depending upon the sine of alpha. And here 1 minus cos ny by neta square is nothing but modulus of y. Now here plus or minus 1 is covered by this integral, and then modulus value is covered by this integral. These two integrals we study in our elementary calculus class. Now coming back to our number of real roots. Now here you have this formula. This nothing but Fourier transform of our original Dirichlet function formula which we have enunciated earlier in our slide, before slides. This is nothing but Fourier transform of that integral. Right. Of course, when I started reading this, I didn't understand that how he arrived at immediately cos and other things. Only after many years, I could understand that this is nothing but the Fourier transform of the Dirichlet integral that we have studied earlier. Now here, look at this. This lemma 2, f of t is continuous and continuously differentiable, and it has finite number of turning points. F dash t vanishes, then the number of zeros of f of t is given by the formula. Here, look at this, the earlier formula and this formula, and that's why I put this Cox idea of counting number of zeros. This is nothing but Fourier transform of your delta function which I introduced earlier. Right. Cox idea, look at this, cos psi f of t, f dash of t, because looking at that cos function formula, which we have studied earlier, now we go again, it is coming in the form of sine function, right? Again, where the plus sign is attached if f t is increasing between alpha j and alpha j plus 1, minus sign is increasing if it is decreasing. So, thus we get a formula, how this number of counting the number of zeros using this integral is obtained. Just evaluating and understanding the two basic integrals of the basic calculus class. Right. Now idea, use cosine Fourier transform for direct delta. This is what I was telling. Right. Fine. This is a delta m minus n equal to cos mx cos nx dx. And using this idea, we could evaluate this, or we could give meaning for our integral. Now, look at this. Let's see that. Buffon's needle problem. In 1777, Buffon has following problem. Drop a needle of length L on a plane containing parallel lines in a parallel line or in a notebook. Equally spaced distance parallel lines space a distance d from each other. That means the distance between the lines is d. Expected number of intersections of the needle with these lines is 2L by pi d. Buffon assumed that L equal to d. But the restriction is not necessary. Consider the sphere with the fixed great circle. Draw a needle, small piece of great circle on the sphere at random. Consider the expected number of intersection of the needle with the great circle. Thus, the expected number of intersection of the curve with the random great circle must be L by pi, where L is the length of the curve. Fine. The length of the curve gamma equal to pi times the expected number of intersections of gamma with the great circle. Now, connection with the random polynomials. Consider a curve on the unit sphere in the Rn plus 1. Imagine that there is an unit sphere in the n plus 1 dimensional space. Now we consider a curve and consider the polynomial Pn of x, where the k equal to 0 to n a k x k t. Let P be the equilateral and perpendicular to the vector P, where the P is a0, a1, a2, an vector. Clearly, gamma t belonging to P of t for the values of t, where gamma t is. There are values of t for which Pn of t equal to 0 means 0. Yes? The number of intersections of gamma with the P perpendicular, number of real zeros of Pn of x. So, using this idea, the number of real zeros is the length of gamma divided by pi. And Grafton formula.
Hello, there is interruption in the talk. Please mute your mic.
The Crafton formula, which expresses the arc length gamma in terms of integral over the space of all oriented lines. Actually, in our MSc course, we teach all these things, but here all the basic ideas are used to evaluate the expected number of real zeros of the random polynomial. Now look at this. Now we are interested. The interesting gamma by the random great circle is equal to counting the number of real zeros of this polynomial. We define models as the area swept by gamma counting the multiplicities. If gamma is a rectifiable curve, then the Crafton formula is this. Now it all amounts to say what is modulus of gamma, right? This modulus of gamma is evaluated, is nothing but the length of gamma. How this length of gamma we teach here? Look at this. This is the formula that we teach in our MSc course or BSc course. And that what is the length of gamma? This is nothing but norm of the derivative of gamma t dt, because this formula is well known. Using this formula, again we concur with the expectation of n of t, arriving at this Cox formula. So this is the proof given by Edelman and Costa. See that he has given a geometric way of calculating the average number of real zeros, considering the unit sphere in the Rn+1 dimensional space, and then how it curves the circle and how many intersections are taking place. That intersection is associated with the zeros of the polynomial, and using the formula of length of the gamma, and we arrived at expectation of n of t. So this is the method used by
Hello, please mute your mic. When the talk is going on, please don't interrupt.
It's a fourth method, zero counting method. Dash and offer.
No, it is bad. Don't interrupt.
Google.
Please continue and try to close it in 5 minutes.
Yeah. Now the addition offered 1956 average number. This n star of t equal to, so this is very unknown. If f of a and f of b less than 0, that means there is a cross. If it is equal to half and it is greater than 0, number of zeros equal to 0. Therefore, now this n is approximated by n star. This is another way of counting the number of zeros. This formulation, and this formulation rather offered his student when he is from Orissa, and then he came to Orissa and they established the school of random polynomials, I could say. His students developed a lot of work. Still people are working on this in Sambalpur University. From there, one thesis of Mvk and Das, it came to Annamalai University because that thesis contains Professor Ganapati Iyer's work plus random polynomials. Ganapati Iyer handed over the thesis to Narayanan to evaluate the thesis. Then he gave that work to Professor Amandam and then to me and Ranganathan. So we started working on this random polynomials in Annamalai University. Okay, now the other sharper result is 2 by pi log n. The analysis in the paper is very tricky, but there is one doctoral thesis by Stevens. He uses a different method. It's a differential geometry method to find out the number of roots and then variance also he has calculated in his thesis first time, but it is not published, but it is in the thesis. He only pointed out there is a lemma 14 of Yardash and offered. There is some error. It's a footnote remark in his speech in thesis. The thesis copy was with the Professor Sankaranarayanan. I came to know about that and the lemma 14 in that Yardash paper. There is some error in that paper. But the results and other techniques are interesting. There is still that error is not rectified. Littlewood offered to have laid a strong foundation in the theory of random polynomials because, and from there, what happened to the polynomial?
Hello. Mute your mic when you are speaking to someone else.
35 వరకు ఉంది.
The presentation is getting interrupted.
11:35 start అయింది.
12:35 వరకు
Conclude in 2 minutes.
అంటే
I will stop.
వేరే అన్న 11:35 స్టార్ట్ అయింది.
Yeah.
12:28 కానీ అట్లా స్టార్ట్ అవ్వలేదు. 11:35 స్టార్ట్ అయింది.
ఇక్కడ ముగ్గురు ఉన్నారు. మూడింటిని కృష్ణమూర్తి గారే హ్యాండిల్ చేస్తున్నారు. ఒక అతను జాయిన్ కాలేదు, సుబ్రహ్మణ్య ఇంకొక అతను జాయిన్ కాలేదు.
12:35 దాకా కంటిన్యూ అయిపోయామంటారు.
ఇక్కడ యు ఆర్ టాకింగ్ క్రాస్ టాక్ వస్తున్నది.
Sir,
you mute yourself. Mute yourself.
Shall I continue?
You can continue, sir, please.
Okay, thank you.
Okay, fine. Now, Wilkins has evaluated an integral where it is an infinite series format and where he has given A2 and A4 and A1, A2 equal to 0. This is an unexpected discovery. What is the open problem here is whether one could generalize the result for any odd P, right? A0 evaluated, A2 evaluated, A4 evaluated, A1 is equal to 0. Is it, what happened to A6, A7, A8, till date we don't know. So it is an open problem. Now look at this Cox curve density. It is concentrating on +1 and -1. When you look at that, this is a simulated result. When the simulation result, it is giving that the roots are concentrating on +1 and -1, and in the density of the roots. Therefore, thus I have taken different polynomial degrees and how they are. Now look at this, the last one, how they are. The roots are showing that it is only on the +1, -1, and +1. Right? The Cox curve has two peaks +or-1 with the height n by 2 pi root 3. This is in agreement with the results of Yardash and Turan, right? Then asymptotic results obtained by various people and upper bound and lower bound for this movement that is also found out. Here you can see that what is the upper bound for expected number of real roots and lower bound for expected number of real roots. So these are all different studies. Probabilistic bound is one, and here this for expectation is in another area. And asymptotic result is 2 by pi log n. Now, this is uniform over -1 +1 and equally distributed +1 or -1. That means only 2 point Bernoulli distribution. In Bernoulli distribution and Bernoulli distribution, you will get 2 by pi log n. Logan and Shape generalized. What will happen? See, the question here is, the woman's assumptions are not involved here. Is there any connection between the existence of the moments and the result? Here, it is conspicuous that we cannot say explicitly whether that variance or moments of any order, it is showing in there, because otherwise, why you have to assume that moments for the random variables? Now, Logan and Shape, then they have studied the stable case and the Cauchy case. When the coefficients follow probability law, exponential minus x to the power of alpha. Alpha is lying between 0 and root 2. Here, this expectation of this real roots is c times alpha log n. Now look at this alpha. What is this alpha? It is the moment condition here. When alpha equal to 2, it is Gaussian. When alpha equal to 1, it is Gaussian distribution. So that now this result shows that asymptotic result of average number of real roots depends on the moments of the random variable. Here is a clue that we are getting it from this result. Logan and Shep, 1968. See, look at this Cauchy case. Cauchy case he has evaluated. And then CAC result is C by 2. C of 2 is 2 by pi. But whereas in the case of Cauchy case is this. Now that 2 by pi is 0.636. This is only an approximate value, the decimals. This paper is a beautiful but difficult and highly technical one. Now look at this dash and the offered result of 56. This is independent of Cox theorem. Neither of these imply the other. That is, Cox method is different. Dash and the offered method is a. You know dash about his contribution on this random polynomial is also very, very fundamental. But people are working on the random polynomials, they cannot escape the idea of dash and offer. Now, assume that AKs are dependent random variables, assume the lower bounds, upper bounds. Okay, an excellent piece of work on the theory of random polynomials, work by Sambandam thesis. His thesis was recommended by the syndicate of the Annamalai University to publish it as a book. In fact, when I was there, I tried my best to bring it as a book. But meantime, he went to States and then settled there. And then there, along with the Barsha Raid, he published his thesis work along with the other published work, and he has written a book which published by the academic press on random polynomials. This is a story of how this random polynomial rooted in India and what is the outcome of the route that took place in Sambalpur University, and then now it is in Annamalai University. Now how it is in the literature, how we have now. Now, PhD thesis, the thesis work, the entire thesis, that a constant correlation. You know that I have already noted down one constant correlation for cubic polynomial case. Now here for n, degree n, he assumed a constant correlation. That because of the correlation, that a number of real roots reduced to 1 by pi log n. That is when the correlation is lying between 0 and 1. So this is the remarkable result. This result, this is what I was telling. When the correlation is 0 and 1, in mobile phone, you are not hearing, you are having the disturbance. Like just now we had the disturbance. Why we have the disturbance? Because they have created, and then one voice and another voice collided, and we could not hear my talk to the audience. This is the application of random polynomial, right? When this 0 less than rho less than half, this is called autocorrelated random variables. Again, it is 2 by pi log n. So whenever this is the remarkable result, right? And then in the case of variance, again, correlated case we have studied. For independent case, Maslow was a result, a Russian lady. And then that paper also contains a computational error, but I corrected it and published it in another paper. So now here the asymptotic estimate of the variance is when 0 less than rho less than 1, we have again it is half of the Maslow was a result. Half of a Maslow was a result here. But whereas this is the original result, 4 by pi pi, 1 by 2 pi log n. And then here it is half of 1 by 2 pi, 1 by 2 pi log n. So this is the variance that we got it for the number of variance of the number of real roots of random polynomial whose coefficients are dependent normal random variables. I think I will take chance to stop with my lecture because I want to give way for another speaker to come to the stage. Thank you very much, sir.
Very good. Professor Tangraj, you should have been given some 10 hours to present it because it will require a lot of time to present it.
Because there are another pages are there. But
Yeah,
anyhow,
I know.
because of the time.
Yeah, this is quite interesting, but requires a lot of analysis, heavy analysis.
Yes, yeah. This is what because you know my Viva-wise examiner was a Bhanumudi. Then he knows that each and every work of the thesis. Then in the interview, people ask me questions. I never answered anything. He only answered. What is that? He has done. That is the when I cannot forget my interview in the Madras University.
Oh,
Yes,
okay.
I never answered a single question because he never allowed me to talk. He
Oh.
only answered.
Very good. Yeah. Okay, Professor Venkatarajan, thank you very much for the excellent talk.
So I dedicate this lecture to Professor Bachirajan and Professor Kannan, to whom both of them are very close, very close till their last breath. We were in contact. Anyhow, I'm very sorry, but anyhow, my first presentation took place at Sri Venkateswara University under the chairmanship of Professor Bachirajan. Right? At that time, I was also working on the law of iterated logarithm. So this is the story, how I connected with the Professor Bachirajan. Of course, Professor Kannan, he is a bird from our nest. I think he was a lecturer in Annamalai University, Department of Mathematics. Thank you very much for your patience.
Okay. Now it is a turn of Professor Uday Bhaskar. Professor Uday Bhaskar, you are there? Hello?
Is there.
Sir, I am here, sir. I am here.
Okay, please start. You have to do it very quickly. They may mute you anytime. We don't have.
Tell me up to what time I should go, sir?
No, you can take go up to 1 o'clock. There is no problem. But then this organization may mute you because they have another session at 12:30.
Fine, sir. Still.
Okay, Professor, you can remove the your presentation.
Stop sharing. Professor Pagraj, stop sharing.
Yes.
You can see at the bottom.
Bottom
or top. Either way you are available.
I don't know how to come out.
Are you in Abhimanyu's Chakramukhya?
Yeah, I think I came out.
No, it is not gone. Still it is there.
Still?
Sir, if you are talking about
at the top, you will find a stop sharing. You hover your mouse to the top. Please hover your mouse to the top.
Yes, where? Yeah.
Okay, good. Now, Professor Uday Bhaskar?
Yes, sir. I am here, sir.
Oh, well, Professor Uday Bhaskar, next speaker, he was with Professor S.K. Srimansan for the doctoral degree. He has done extensive work in stochastic calculus related work and some other areas. Well, he's a very good teacher, very good researcher. He worked with the higher education department in Madras University or Tamil Nadu. He was a professor, and then he joined the as a technical higher education. No, I'm sorry, director of collegiate education. Subsequently, after his retirement, he was with the Weltech University. Still, he continues there. Well, Professor Uday Bhaskar, please start the talk.
Thank you.
It it is on stochastic bio models. He has plenty of publications, really, with all the number. So quite interesting applied area. Okay, please.
Thank you, Professor Krishnamurthy. At the outset, I don't know how I am going to present today's talk because I am very much affected by the sad departing away of my close associate, Professor Kannan. Krishnamurthy knows, everyone knows that how much I was involved with Dr. Kannan whenever he visited India. And it's really, my heart is very heavy now. I don't know how I am going to present my talk today. Only today, through the words of Krishnamurthy, I have come to know. Usually, Professor Krishnamurthy used to contact me quite and then to tell about the health of Professor Kannan. I don't know how I could not receive the departing away of my close associate, Dr. Kannan. Anyway, my heart is aching. Anyway, I will present this talk today. I'll balance myself. Thank you, Professor Krishnamurthy, and thank you, Jayashree ma'am, for inviting me to this conference. The talk that I am going to present today is on stochastic bio models. Actually, the bio models are very deep area. One cannot present everything in 30 minutes lecture. So I concentrate myself on one particular bio model. It is a model on Cosmogenesis. All of you know what is Cosmogenesis, how cancer is formed in a living being. Actually, the talk was planned for 2 days, but now I will cut down it for 30 minutes. Stochastic bio models with special reference to Cosmogenesis. For this, you require basic probability and also rudiments of stochastic processes. In particular, it is enough if you know about Poisson process. Of course, you should know the probabilities laws. Cosmogenesis, the development of cancer, is believed to involve two processes, transformation and growth. Transformation is the occurrence of one or more changes in a normal cell, which render it capable of generating a tumor. Whereas growth is the process of multiplication by cell division, whereby a transformed cell produces a colony of descendants, offsprings, called a clone. When I say transformation is the occurrence of one or more changes, these changes are normally called mutations. Normal cell mutates. You may have a single mutation or multiple mutations. But I will restrict myself to single mutation. That means there is an intermediate stage. Normal cell mutates itself into an intermediate cell, and that intermediate cell develops into a tumor cell. This tumor cell, never dies. It has got only the multiplicating power. That is why the clone is formed. From one single mutated cell, a clone is formed. When the number of cells in the clone is large enough, the clone is called a detectable tumor. Some tumors called malignant tumors, or these things already you know, but anyway, in a conference, I should have persons who want to know much about the modeling aspect. That is why I am presenting Cosmogenesis or cancer formation, how cancer is formed. Some tumors called malignant tumors or cancers are capable of such invasive growth that they can kill the host. Other tumors called benign are capable of extensive growth but do not kill the host. Tumor production is possible because of a transformed cell has a higher net multiplication rate than a normal cell. That is, it has a higher rate of proliferation, less rate of loss of cells. Cosmogenesis can be caused by certain agents called carcinogens, among which are certain chemicals, ultraviolet light, and some viruses, in fact. Quantitative theories of carcinogenesis attempt to relate the frequency and the time of occurrence of detectable tumors to the concentration and the potency of the carcinogen, the age and susceptibility of the host, the duration of exposure to the carcinogen, etc. The theories can be tested by comparing their predictions with the observed human cancer incidence and with the result of animal experiments in which cancers are produced by the application of carcinogens. This is very crucial. But we have to accept the cruelty. There are two main reasons for formulating such theories. One is to elucidate the mechanism of carcinogenesis. The other is to help determine allowable concentration of carcinogens in the environment. That is what the present modern day world does in agriculture. And to estimate the consequences of exceeding these concentrations. What we eat, they contain carcinogens. I'll skip these slides. Various types of cancers. Yes. I'll straight away go for stochastic model. Already in 1953 and Armitage and Dahl 1954 were the pioneers to propose stochastic models for cosmogenesis. They are statisticians, of course. In their models, the point of view is that cosmogenesis is due to the progressive transformation of a normal cell to a malignant cell by a finite number of stages. And their models are now called multi-stage clonal expansion models, MSCE models, multi-stage clonal expansion models. It is now universally accepted that cosmogenesis is a multi-stage process which is based on the hypothesis that a few changes, each irritable, when somatic cells divide in the tissues, are needed to alter an ordinary epithelial cell into the progenitor of a carcinoma. Wait a minute, please. There is a disturbance going on.
Sure.
Right. In essence, the multi-stage Codal expansion model is actually an initiation and promotion process and is described as follows. In the K-stage model of Cosmogenesis, there are K stages sequentially where the first K-2 stages are called pre-initiated stages and the K-1 stage is called initiation stage and the Kth stage is called the malignant stage. Normal susceptible cells arrive in the first pre-initiated stage according to a Poisson process with intensity mu0 into x, where x is the number of normal susceptible cells. A cell in the ith pre-initiated stage can divide into one ith pre-initiated cell and one i+1th pre-initiated cell with the rate. Yes. Yes.
Professor, press F5.
Please.
Professor,
Yes, sir.
please press F5 button. It will be maximized. Press F5 button so that it will be maximized.
Is it right now, sir?
No. It is visible, but you can maximize the screen.
I've already
pressing
maximized it,
F5.
sir. I've already
Press
maximized it, sir.
So F5 button, top row. Function button F5.
Yes, sir. Yes, sir.
Please press it.
Is it correct, sir?
No, sir. Oh, sir, please continue. No problem. Please continue. Professor, please continue as it is. Sir, please continue.
Yes, sir. I will continue, sir. Is the screen visible, sir? Hello?
Yes, yes, yes.
Yes, sir.
Is it visible?
Yes.
But it can be extended in long run.
Long range. Yes, sir. Yes. Initiation and promotion experiments in animals have suggested that at least 2 stages are necessary for tumorigenesis. All pre-initiated stages can be clubbed together as a single stage, and hence it is sufficient to deal with the 2-stage clonal expansion models of Cosmogenesis. This is very important. How this MS multi-stage has now become a 2-stage. All pre-initiated stages can be clubbed together as a single stage, and hence it is sufficient to deal with the 2-stage clonal expansion model, TSCE. Armitage and Dahl, 1957, proposed a 2-stage model in which first stage takes into account an enhancement of the rate of multiplication, leading to an exponential growth of intermediate cells, so-called pre-initiated cells, and the second stage leading to uncontrollable production of cancer cells, malignant cells. Kendall, 1960, developed a TSC model with the first stage leading to
Sorry to interrupt.
The presentation is not there.
Can you please press Alt plus F5 so that it will present in a bigger note? Can you please start your presentation and click Alt plus F5 so that your presentation will be bigger, visible to all.
Now it is visible, sir?
Oh, very good.
Yes, sir. It's now visible. Yeah. Thank you, sir.
Thank you. Thank you very much, sir.
Codal, 1960, developed a TSCE model with a first stage leading mu I is equal to 1, 2, etc. up to k minus 3. A k minus second, k minus 2 pre-initiated cell can divide into 1 k minus 2 pre-initiated cell and 1 initiated cell with the rate mu k minus 2. Once a cell is initiated, it expands clonally via to the production of intermediate cells in the second stage, leading to the generation of malignant cells by means of a birth-death process. Knudsen, 1971, formulated a two-mutation model for hereditary and non-hereditary forms of retinoblastoma, which occurs only in young ages, less than 6 years of age. Extending the model of Knudsen, Mvk and Wenzel proposed a two-stage model for the incidence of childhood and adulthood cancers by allowing growth and differentiation of both the normal and pre-initiated cells. These models are now called Mvk models of cosmogenesis. Little, 1995, extended Mvk model by taking into consideration genomic instability. Zeng, 1995, studied Mvk model of cosmogenesis with Erlang distributed cells lifetimes. The TSC model of Mvk and Wenzel is based on the following assumptions. It is just to follow the model, how it has been formulated. All cells, normal as well as intermediates, behave alike and independently. In a small interval of time, t to t plus delta t, a normal cell existing at time t may divide into two normal cells with probability L delta t plus O delta t. It may divide into one normal cell and one intermediate cell with probability n into delta t plus order of delta t, small o of delta t, and it may die with probability d delta t plus O delta t, where L, N, and D are positive constants. In a small interval of time, an intermediate cell existing at time t may divide into two intermediate cells with probability alpha delta t plus O delta t. It may divide into one intermediate cell and one malignant cell with probability B delta t plus O delta t, and it may die with probability mu delta t plus O delta t, where alpha, beta, and mu are positive constants. So this is with regard to intermediate cells, division of intermediate cell. The next one is very important. The probability of more than one event taking place in the interval t to t plus delta t is order of delta t. Once a malignant cell is produced, it never dies. It grows into a clone with probability 1. So this is a very strong assumption. Once a malignant cell is produced, it grows into a clone with probability 1. So this is actually the Mvk model. This Mvk model is now extended to further several people by taking into account the mutation aspects, and those things I am not going to present here. I will just confine myself to the Mvk model, how it is very interesting to derive the equations governing the model. Let x of t, z of t, and w of t be the number of normal, intermediate, and malignant cells at time t. Then the three-dimensional process is Markov, because you have the rate constants. It becomes a three-dimensional Markov process whose state space is ijk. Let xi x ZWT be the probability generating function for x of t, z of t, w of t, starting with one normal cell at time 0. At time t equal to 0, we start with one normal cell. Similarly, let phi ZWT be the probability generating function for two-dimensional process. Z of t, w of t. Z of t is the number of intermediate cells. Wt is the number of malignant cells at time t. It is a two-dimensional process starting with one intermediate cell at time 0. Starting with one intermediate cell. Actually, this corresponds to single stage process, and this corresponds to two-stage process. Normal cell becoming intermediate cell becoming malignant cell. Here it is, you can view in, this is a very important thing that one must note. You can view like this, intermediate cell into malignant cell. If you have two-stage process in your mind, or if there is a one-stage process only, that is a normal cell becoming a tumor cell, you can view this Z of t be a normal cell population and WT be the cancer cell population. So single stage also you can consider this. It can be shown, this is a very important thing, integral equation. Psi of t is equal to x into e power minus kt plus integral 0 to t e power minus ku L into psi square t minus u plus n into psi of t minus u, pi of t minus u plus d into du. And this integral equation can be derived by simple probability laws. You are starting with one normal cell at time t equal to 0. That normal cell continues to live beyond t is taken care of by this term x into e power minus kt, where k corresponds to L plus n plus d. L is the division, L and the n are division rates, d is the death rate. L corresponds to dividing to two normal cells, n corresponds to dividing to one normal cell and one intermediate cell, and d corresponds to normal cell dying out. Therefore, L plus n plus d corresponds to k, that nothing happens up to time t. Therefore, normal cell lives up to time t. That is taken care of by this first term.
So d must have a negative sign, I suppose.
No, d is a positive constant.
Yeah, that's right. But then that sign must be negative because it is a removal.
E power minus kt.
No, what I mean is that d, it is a removal.
Removal, right?
Normal cells.
Yes.
So that much.
Normal cell becoming a dying out. Normal cell dying out. Rate is d.
Okay. Oh, okay.
So x into e power, my typing is very poor. X into e power minus kt. Actually, I wanted to type it in LaTeX. Somehow I wanted to try in this PowerPoint to familiarize with my PPT. This is why I tried this. Anyway, Tangaraj did not feel happy about my slides. I compromised with him. X into e power minus kt plus integral 0 to t. How this term comes? See, in the interval 0 to t, you catch hold of the first event that is happening. This is no event happening in the interval 0 to t is taken care of by this term x into e power minus kt. Suppose one event takes place in the interval 0 to t, catch hold of the first event. The first event will be either dividing into two normal cells. That is taken care of this by term L into, that is the normal cell with which you started at t equal to 0 divides into two normal cells. Therefore, two independent populations arise because of the presence of two normal cells at time u. Therefore, you multiply psi square of t minus u are getting remaining time. Remaining time is t minus u. At time u, the normal cell divides into two normal cells. Therefore, two populations, independent populations are generated. And contribution by the two populations is taken care of by this psi of t minus u into psi of t minus u. So that is taken care of this. Up to u, nothing happens. E power minus ku into, in the interval u to u plus du, the normal cell divides into two normal cells, and therefore two independent populations are generated, and therefore the contribution by the two population will be psi square of t minus u. Or in the interval u to u plus du, the normal cell divides into one intermediate cell and one normal cell. Therefore, you have the rate is n into du. This is the population generated by the normal cell. This is the population generated by the intermediate cell. Because I already told you the events are independent, therefore, you multiply n into psi of t minus u into phi of t minus u. Or it simply dies in the interval u to u plus u. Nothing is plus d. So that is how this integral equation arises. This is an interconnected integral equation because psi is present as well as phi is present. Phi is the generating PGF corresponding to the two-dimensional process. Now let us come to phi. Phi of t will be equal to, you are starting with one intermediate cell at time t equal to 0. So nothing, similarly, you have argue z into e power minus kt plus, where kappa, not k, kappa. Kappa is alpha plus beta plus mu. Alpha is dividing into two intermediate cells. Beta is the probability, beta is the rate corresponding to one intermediate, one malignant, and mu is the death rate for the intermediate cell. So e power minus kappa t plus integral 0 to t, e power minus kappa u, that is nothing happens up to time u, and in the interval u to u plus du, two intermediate cells are produced, that is this term, alpha into phi square of t minus u, and in the interval u to u plus du, the intermediate cell splits into one intermediate and one malignant cell. Therefore, I am having beta into the population generated by the intermediate cell, phi of t minus u in the remaining time, and into w, because I already told you the malignant cell, once it is produced, it never dies, it leads to a clone. So w plus, this is not d, typing mistake, it must be mu, it must be mu, not d, mu into d. Wait a minute. Mu into du. Yes, this is mu, not d. I don't know how to correct it now. I will correct it later. In the above equations, the dependence of psi and phi on x, z, and w has been hidden. From 1.1, it follows that psi of t is equal to, I can convert this into a differential equation by using a simple integration formulas. I can convert this into a differential equation, and this is the differential equation. Where is it? Yes. Leads to derivative of psi with respect to t, partial derivative, will give you L into psi square of t plus n phi of t minus k into psi of t plus d, where this is the partial derivative. This is the partial derivative. Similarly, the equation 1.2, by using simple integration rules, you can convert this into a differential equation. That is dou phi by dou t is equal to alpha into phi square of t plus beta w minus kappa phi of t. These two are in interconnected partial differential equations. Interconnected partial differential equations. But solving these two equations, this system 1.4 and 1.5 is not very easy. You can go for the moments. Moments can be solved. let mxt, mzt, and mwt be the mean number of normal, intermediate, and malignant cells at time t, starting with one normal cell at time 0. Similarly, small myt and small mzt be the mean number of intermediate and malignant cells at time t, starting with one intermediate cell at time t equal to 0. And differentiating 1.4, 1.5, you get the equation for the, this is a differential equation for the mean number of normal cells. We can straight away solve this exponential growth. And similarly, intermediate cells, I can get this. After solving this, substitute this here, you can get the mean number of intermediate cells. And next, you can get the mean number of malignant cells. And using the equations 1.4 and 1.5, you can also find the hazard rate. That means up to time t, the malignant cell has not been produced. That can also be found. And there are more things that can be done with regard to this Mulgaonkar model, which I'll just point out, and I think I have to wait, what has happened now? Recently, one of my students has developed the two-stage models with regard to the taking into account the mutational aspects of the cells, and whereby she has introduced randomness, random environment in the division process, and thereby some complicated models have been formulated, and in fact explicitly solved to yield the moments and also the hazard rate. And the results have been compared with the already available results numerically, and it was an agreement, and thereby we could publish some of the results of the thesis in some Scopus journals. I think I have to stop here.
Okay, Professor Devaskar. Well, as you said at the beginning, it is a 2-hour talk. It is not for just half an hour. You have to perhaps introduce several other things. It is a really beautiful talk. Probably many youngsters can take up their research in this area.
Thank you, Krishnamurthy sir.
Thank you, sir. Thank you, Professor Krishnamurthy sir, for chairing this session. And speakers, Professor Arivarignan sir, Professor Thangarajan sir, and Professor Uday Bhaskaran sir for sharing your valuable knowledge with all of us. Now, it is a great pleasure for me to introduce Professor P. Rajashekhar Reddy sir, Honorary President of ISPSC and retired Professor of Statistics from SV University Tirupati and former Registrar. The Chair for Contributory Papers. Sir, I request you to occupy the chair and conduct the contributory papers session in the stipulated time.
Yeah. Good afternoon. Now the time is almost 1 o'clock. There are, I think, 7 papers are there. So now I will call for all the presenters first. Number 125 is Lakshman Rao. Yeah, Lakshman Rao is available here. Hello. I'm audible?
Yes, sir.
Professor K. Lakshman Rao is audible. If not there, then Madhulata available. D. Madhulata. Hello. I am audible.
Yes, sir, you are audible.
Yeah. Okay. Number 3, 127. Durga Aparjita. J. Durga Aparjita. So this is operation research, but now the third Durga Aparjita is not available. Then I will ask Bitika Das and Gautam Saha, applications of operation research techniques.
Yes, sir. I am present here.
Yo, so number 128, applications of operation research techniques for modeling of public healthcare management. So now Bitika Das and Gautam Saha. So now I request Bitika Das, yeah, and Gautam Saha. Okay, and Gautam Saha. So please present and within 10 minutes, because I'm giving time only 10 minutes because the time is already 1 o'clock. Okay, anyhow, some of the absentees are there. So 1 o'clock, 10 o'clock, please 10 minutes you take it and finish up this. Okay.
Yes, sir. Is it visible?
Yeah, it is visible. Please introduce yourself and
sir, is it the PowerPoint is visible that applications of operational research techniques for modeling?
It is visible. It is
Please press Alt plus F5 for a better presentation.
Yes, sir. I am Dr. Gautam Shah, working as a associate professor of statistics in an undergraduate college at Agartala, Tripura. So today I want to present my paper, that applications of operational research in healthcare management.
Just sorry to interrupt. Can you please make your presentation bigger by pressing Alt plus F5?
Yes, sir.
Yeah. Yes, sir.
Okay. Actually, basically, this is the definition of operational research, which was given by C. R. Churchman. We know everyone who is the one of the pioneers of operational research. So, operational research is different from the clinical trials, different from the clinical research is different from clinical or epidemiological research, whereas operational research examine the health care systems rather than focusing on an individual or group of individuals. OR has been increasingly recognized as a vital, the strengthening of health programs. The true value of OR is to health programs is not only the inclusion in global plans or the allocation of resources, but more importantly, the improvement of health via the impact of research results on programmatic and policy decisions and on practice. Now, the healthcare systems in India. Healthcare has become one of the India's largest sectors, both in terms of revenue and employment. Healthcare comprises hospitals, medical devices, clinical trials, outsourcing, telemedicine, medical tourism, health insurance, and medical equipments. There are often many different options for improving healthcare policy or improving current practice in healthcare organizations. The optimal solution among those options, that is the solution that best achieves a defined goal, such as maximizing patient quality of life or minimizing the patient waiting time for services, may not be readily apparent. Constraint optimization method use mathematical techniques to help efficiently and systematically identify the best, which is the optimal of all possible solutions to a problem, while considering the relevant constraints such as budget limits or staffing capacity. There are two main approaches for carrying out OR in healthcare. The first approach involves the analysis of secondary data as retrospective record, reviews, and utilizing such data that is already generated in the programs. The secondary approach is carrying out the primary level research. Now, the importance of healthcare, which affects all the society, growing population, more chronically ill, comorbidity, increasingly advanced technology, expenditures growing rapidly. scopes and opportunities of operational research in healthcare sector. Applications of OR methods to medical decision making often seek to find an optimal choice among alternatives. In medical decision making, there are 4 commonly considered perspectives: patient, physician, third-party payer, and societal. New trends in medicine will provide opportunities for the development. Personalized medicine. So, personalized medicine, which is noted to be the future of medicine. Liebman in the year of 2007 emphasized the customization of healthcare intervention for individual patients using each person's unique clinical, genetic, genomic, and environmental information. Personalized medicine may lead to alternative interventions for patients. This may require the use of advanced mathematical modeling, such as large-scale optimization, to choose the best intervention. Patient's behavior. An important issue in medical decision-making understands the influence of patient's behavior. One example is patient compliance to medical recommendations, which can significantly influence any recommendations about medical decisions. As WHO 2003 reports, adherence to therapies is a primary determinant of treatment success. Poor adherence attains optimum clinical benefits and therefore reduces the overall effectiveness of health systems. It is therefore crucial to consider the effect of poor adherence in optimizing medical decisions and tailoring clinical recommendations based on patients' behavior. This is also a potential area of applications for OR methods, where medical and behavioral sciences, this is an important part of this research paper, medical and behavioral sciences need to be integrated. In particular, there is a need to develop mathematical models that represent human behavior to better understand its role in medical decision making. Natural history of disease. Most medical decision making studies require data-driven medical mathematical model to represent the progression of a particular disease without any intervention. It has been observed that no clinical data about the natural history of diseases such as breast cancer or end-stage liver diseases is available. It is necessary to develop and use a theoretical natural history model. In the future, OR methods may provide ways to estimate natural history models. Future medical interventions. Most medical decision-making studies estimate disease progression and treatment outcomes using current available treatment options. These studies assume that treatment options remain constant in the future. On the other hand, medical research and development often leads to new and improved therapies, such as in HIV and organ transplantation. As a result, in some cases where innovations are anticipated in the near future, these studies using stochastic models in medical decision making. Challenges and issues in process of OR in hospital. While working in a hospital administrator faces different types of issues. Like in a hospital, there are staffs with the different skills, from a super specialty doctor to a housekeeping staff. In such a scenario, there are chances to conflict in different in between the staff. The major peculiarity of a hospital is that it is emergent in nature. Hospital has to be. Yes, sir. Yes, sir.
Under 3 minutes. Yeah.
Okay. Okay. So these types of the applications of OR in hospital management, and the operation theater timings are divided into various slots according to type of surgeries, any misschedule, and these types of this thing. In a particular hospital, there are different departments working at the same time. So departmental issues may happen in hospital. Overload of work of nurses may lead to poor nursing care of patients. Now, applications of OR in different segments of hospital management. Patient scheduling, this is very important thing, how we want to schedule the patients, where appointment is an important factor of patient scheduling. Now OR models are developed by authors to answer the given 3 questions. How many patients should be scheduled on a given day, and how many appointments, whereas what will be the optimal sequencing? This is an important part of here. What is an optimal sequencing of heterogeneous patients? Resource scheduling, where resource like that, health professionals, rooms, equipment, supplies. Staff scheduling, where important thing is physician scheduling and is nurses scheduling. And here, nurses rostering is an NP-hard, that is the non-deterministic polynomial problem, which involves two steps. The first step is to determine the number of staff, and the second step is to allocate them in the time horizon. Whereas the discrete event simulation model evaluates the improvement or in client-centered key performance indicators, including wait times for the weekly optimized models. Medical records department, MRD, this is very important for any hospital to maintain some database maintenance. The most important tasks of MRD include supporting and protecting current and future care of the patient, official activities, continuous training, like that. Now, other things are the patient admission process, including registration and identification purpose, filling patients' records, evaluating MRD services, like that. Now, storeroom management, this is also a very important thing where we can apply ABC analysis for the vital few and trivial many things. So this is conclusion of my paper. The OR is distinctive instrument leading to greatest benefit to health system and user at lowest cost. Whereas teams of academicians, policymakers, program managers, epidemiologists, biostatisticians, community health specialists, and health economists should join hands to execute quality of operational research to answer public health system relevant problems and solve them. Thank you.
Thank you, Saha, Gautam Saha. So any questions from audience? Okay, if no questions, yeah. So thank you, Gautam Saha, for a presentation of this healthcare management in inventory. Particularly, you have used ABC analysis or something.
Thank you, sir.
Thank you. Okay. So now I request the next speaker is there anybody? Durga Aparjita, Madhulata, Lakshman Rao? Okay, didn't come. R.D. Patel or they say M. Patel is there. 129. Inventory model under three-tiered pricing with two storage facilities and varying deterioration. Is there? If not, the 130 number, optimization of stochastic demand and exponential deterioration type inventory model using evaluation algorithm. Sandesh K. Korade is there? Sandesh. Next one, 131. Firoz Ahmad is there, available? Firoz Ahmad is available? No? Okay, I will read once again. Is it Lakshman Rao available? No? Then Madhulata available? Okay. Then Durga Aparjita? Okay. Sandesh Kurade, Firoz Ahmad. So all are absent. So only one out of 7, only one has presented. Okay. So with this, the session is now we are closing. So this one. So over to the organizers.
Thank you, sir.
Thank you.
With lunch ratio.
Hello. कुछ रिसर्च प्रोजेक्ट कर रखे हैं यूटीसी के मेजर रिसर्च प्रोजेक्ट यूटीसी वाला
Good afternoon.
Professor.
Good afternoon.
Oh yeah,
everyone.
Professor David. Good afternoon. Yeah. Yeah.
Good afternoon, all the professors present over here. It is a great pleasure for me to introduce Professor S.E. Malik, the chair.
Yes, one more thing, madam. No need to give any introduction about me. We should, I think, we should request Professor David Henengel on and to deliver the talk. I will invite Professor David Henengel. No problem.
Okay, sir. Sir, I request you to occupy the chair and introduce the speaker.
Yeah. Okay, so should we start?
Yeah, we can start.
Okay. So a very good afternoon to Professor David Henengel. We are now at the post-lunch session. So in this session, we are going to start with the lecture of Professor David Henengel. So it is my prime responsibility to introduce our speaker, Professor David Henengel, to our audience. Although Professor David Henengel did not require any much introduction, he is a well-known professor of statistics and visited several countries and several universities in one way or the other. So first, I welcome you, Professor David Henengel. And then I have few words about Professor David Henengel. Professor David Henengel is going to speak today on positive stable shared fraternity models based on additive hazards. One more thing is that Professor David is a very sober personality and is a good researcher, and he completed all the services from University of Pune, and he is recipient of various awards also. Professor David Henengel is a fellow of Royal Statistical Society, London, member of editorial board of various research journals of national and international repute, and is a life member of various academic bodies, including some associations, well-known associations, life member of International Indian Statistical Association, life member of Governing Council member and treasurer of Journal of GISA, life member of ISPS, ISCA. And his areas of research are not one, but he has research interest in the field of inference in bivariate, multivariate exponential distribution, selection of better component in two component system, stress strength models, reliability theory, multivariate Pareto and Weibull distributions, characterization, non-parametric inference, many more. Yes. So he has also the vast experience of teaching. Particularly, he has the experience in the field of reliability theory, survival, data mining, linear algebra, probability distributions, parametric inference, and several others. So one can say that he has the wide experience, vast experience, we can say, in terms of teaching and research. So on behalf of the ISPS, I request you please kindly deliver the talk. Professor David Henengel, I welcome you.
Thank you, Professor Malik, for very nice introduction. Thank you for the ISPS for giving an opportunity to share my talk during this conference. Okay, I'll not take much time. Okay, the title of the talk is Positive Stable Shared Fraternity Models based on additive hazard. This is our branch of fraternity model, is the branch of survival analysis. There is a data, that is a survival data involved. The data, survival data is time to event data. There are on the sensor data, there are different types of sensoring involved. Right sensoring, left sensoring, interval sensoring, current status data, and several other things are there. Basically, I'm using the right sensor data with additive hazard and fraternity model introduced. Okay, this is just a brief. I'm just giving the outline of my talk. What is the survival analysis, shared fraternity models, positive stable shared fraternity models. Some I'm using parametric model, some baseline distributions I'm using. then Bayesian estimation of the parameters involved in the model. Then I'm using some simulation techniques, and then kidney infection data analysis based on the kidney infection data, and some summary of tables and graphs. Now, what is survival analysis? It's a time to event data based on the different censoring schemes. I'm taking the right censored here. I'm just going through the basics. The first one is the Cox model given by Cox 1972, Cox proportional hazard model, that is given in equation number 1. The hazard is given by STX equal to H0 T exponentially X prime beta. H0 T is the common baseline hazard function, and X is the vector of explanatory variable, beta is the vector of corresponding regression coefficients. This is a multiplicative model. This I'm not using, I'm just changing this to additive model. That will come in the next equation. Okay, before that, what is the variety term here? That is nothing but a heterogeneity involved in the data. Okay, it may be data, may be either a patient's or some other data, environmental, industry, maybe anything. Okay, and there is always problem of homogeneity. If the data is not homogeneous with respect to the some constraints, okay, that say, for example, patients, if you take for example, all patients are not homogeneous. They have different problems, health problems, different diseases are there, and that we have to categorize. Maybe sometimes it's not possible to categorize, then we miss the information. In that case, there is some random quantity or heterogeneity involved in that. That is called heterogeneity. That we call as a variety term. This variety may be due to genetical factors or environmental factors. Okay, now what is shared variety model? Shared variety model is there is individuals within the group of patients. Okay, take for example family. Okay, common risk may be there. For example, if you take pale data, kidneys or eyes, lungs, and other things, there is a pale data, and the common factor is common risk. That is for both components. There is a common risk involved. Okay, that is called shared between the two components. Okay, that's why it is called shared variety model. It may be existence of a genetic risk factor or some other environmental factors. Okay, and okay, what are the things involved in this variety? See, sometimes we ignore variety because we can't be able to measure it. It is unobserved. Sometimes there are so many covariates to consider. We don't know which covariate is more effective or significant to the lifetime. And that time we just ignore because of too many covariates, and there are some lack of appropriate tools to measure the covariates. That is another thing. And researchers are not aware of the influence of the potential covariates that might exist. Okay, existence of genetic risk factor, that is one example, or environmental factors. There are different types of problems when you measure the unobserved covariates. Okay. Now, variety is an unobserved random proportionality factor that modifies hazard function of an individual or related individual. This is an extension to the usual cost proportional hazard model. Layton 1978 first used to observe random covariates in the multivariate survival models on chronic disease incidence in families without using the motion variety. And next, Whipple et al. Okay, in 1979, he used the terminology variety first time. Okay, this is an extension of Cox model. Okay, this effect of variety is not directly estimated from the data, but is instead is assumed to have unit mean and finite variance. There is some problem when you deal with variety model because non-identifiable problem is there that can be resolved by taking the unit mean. Okay, variety has a unit mean and finite variance. Okay, what happens if we ignore the variety factor? Okay? If the variety is significant in the model and is ignored, then the model will be inappropriate. And the decision based on such models is misleading. If variety is ignored, whatever analysis we do, okay, estimates, maybe either underestimates or overestimates. And AIC, BIC, DIC, these are the model selection criteria. Okay, this will increase if we ignore the variety term. Okay, we must get a model where AIC, BIC, DIC are very minimum, least quantity. The decision based on the model without variety model will go wrong. Ignoring variety effect with finite mean may result negative bias in the estimated time dependence. In general terms, we let heterogeneity go into error term. This will of course lead to increase in the variability of the response as compared to the case when variety is included. Giving the model, okay, I'm just introducing a variety in the usual model. The additive model is given in equation number 2. H naught t given x covariant, what is the baseline hazard is H naught t plus x prime beta. This is the additive model. I'm just adding to the baseline hazard. This can be written as instead of taking x prime beta, I'm taking e raised to x prime beta. Okay, then this quantity will be positive, e raised to x prime beta. Okay, x takes minus infinity plus infinity, then e raised to x prime beta will be greater than 0. Now add the heterogeneity term u prime beta u. U prime is an unobserved covariate and beta u is a regression coefficient associated with that unobserved covariate. And now this I can write in equation number 4 in this term. Okay, that is here. There is another way of writing is e raised to that. Okay, that is the thing. And we get this term. Okay, the hazard is h naught t plus this term. This is a random quantity here. Okay, now z is this term u beta u. Okay. Now cumulative hazard rate can be written as this one. Okay. That is independent of v, t, then I just integrate, then t into this term. Then there is a relation between Serval function and cumulative hazard that can be written in this. Okay. And h naught t is the cumulative baseline hazard function at time t. Now integrate over the z, we get this term, and we substitute the term here, we'll get this one, and that is the thing about this one. This term is take h naught t outside, e raised to h naught t, and the remaining term is a Laplace transform of the random variable z. That can be written as this one with argument. Now this Serval function includes the baseline Serval function multiplied by Laplace transform of z. Now if you take two components, pair data or something, and you get two lifetime t1, t2, conditionally given z1, z and x. These t1, t2 are independent. That is written as this one. I can write just e raised to x prime beta as eta. That is a covariant term. Now this is given x. They are independent. Now when you integrate z, then we get t1, t2 are dependent. we can't separate here T1, T2. Here they are separated, but here we can't separate. Therefore, there is a dependence between T1, T2 after integrating over Z. All right. Now there are different types of variety models in the literature. Gamma inverse Gaussian, positive stable Bauer variance, compound Poisson, compound negative binomial, piecewise gamma, correlated variety, additive variety. I'm going to deal with the positive stable variety model in this paper. There are already written by myself and other authors also on gamma, inverse Gaussian and other things, correlated variety, additive variety and other things. I'm not going in detail. Now let us concentrate on the positive stable variety model. Now, shared variety model that is a special interest for two reasons. First is similar to gamma variety model, the simple form of Laplace transform allows simple maximum likelihood estimation in the parametric model. Second, there exist no moments in this distribution. In practice, gamma variety specification may not fit well. This is the reason why Howard introduced this distribution in the shared variety approach. There are different reasons why we can't use gamma and other variety models, and why we have to prefer positive stable variety model as a shared variety model. Okay. This was given by Howard first in 2000. This is a useful alternative to the other gamma, other variety distributions. There are some other, the properties observed is familial association of the ages of onsets of disease with heterological heterogeneity, where genetic cases occur early and long-term survivors are weakly correlated. Gamma model has predictive hazard ratio, which are time invariant and may not be suitable for these pattern of failures. That is the reason we use positive stable variety models. This is the reason we use this one. Okay, this is a PDF of positive stable variety model with the Laplace transform, this one. Okay. There is some problem of non-identity, and we restrict the parameter alpha delta equal to theta. Now there will be, instead of two, there will be only one parameter in the positive stable distribution. That is given by, now this reduces to this one, with one parameter positive stable distribution, that is PDF is given by this. And this is a Laplace transform. Now use the equation that is a bivariate survival function given Z and X. That is product of these two. When these two are given, that is here. I am just substituting the positive stable variety here. That is the thing. The positive stable variety distribution for this one, Z here. Okay. That is a term. Okay. Z I am integrating out. This is distributed as a positive stable. That we will see in the next equation. Okay. That is here. Integrate over Z, you will get this term. This is a term. Here we can't separate out T1, T2. This T1, T2 are dependent here. Okay. And H0 1 and H0 2. These are the cumulative baseline hazard models, the hazard functions of lifetime T1, T2. And this is a term. Okay. This is a term without variety. This is a term with variety. That is it. This term will go in that case. This will be just theta equal to 1 in that case. That is the thing. When theta equal to 1, then there is no heterogeneity. That means Z is degenerate in that case. And Z is degenerate when theta equal to 1. That is here in this case. Now I use some baseline distribution, generalized log logistic. This is the first baseline distribution. And the survival function of log logistic is this one. Okay. I'm just taking this raised to alpha. That will become generalized log logistic. Okay. Raised to this one. Okay. It's a lemon family that is given by Deshpande and this Purohit in 2005. Just raised to this one. Generalization. Now, the distribution function, cumulative hazard, and hazard function of generalized log logistic distribution. When gamma is less than or equal to 1, failure rate is decreasing. When gamma is greater than 1, failure rate is increasing. The second one is generalized viewable distribution with distribution function and cumulative hazard and hazard function. This is just viewable distribution function raised to alpha that gives generalized distribution. When alpha equal to 1, it will become viewable. When gamma equal to 1, alpha equal to 1, this will be exponential, and different types of distribution will get for different restrictions in the parameters. Okay. Now I propose four models. 2 are priority models, 2 without priority models. Okay. Generalized log logistic and generalized viewable as baseline distributions. Okay. Using the positive stable priority model that is here. 7 and 8. Okay. That is the 2 distributions with and without positive stable priority, taking generalized log logistic as baseline. And next one is this one. This is generalized viewable as a baseline. That is the term. Okay, these are the 4 models, 4, 5, 6, 7 equation. Model 1, model 2, model 3, model 4. Model 1 and 2 are generalized log logistic distribution with priority and without priority. Likewise, model 3 and 4 are generalized viewable distribution with and without positive stable priority model. I'm just going through the Bayesian estimation. One can also do the classical estimation, MLAs and other things. There are so many parameters involved, and there is some problem of Newton-Raphson procedure in the iterative procedure. The convergence of the estimation that is giving some problem. I'm just using the Bayesian estimation to estimate the parameters. Okay. Takes a sample of size n individuals under study. There are different reasons. Okay, when both T1 and T2 are observed, that is one reason. That is given by joint density F1, and F2 is when the first lifetime is observed, second is censored, and third is first is censored and the second lifetime is observed, and both lifetimes are censored. Different reasons are there. These are written in the likelihood, that is this one, N1, N2, N3, N4. 4 reasons, number of observations in the first, second, third, and fourth, respectively. Okay, and sum of N1, N2, N3, N4 is N, sample size. How to get F1 and F2? How to get F1, F2, F3, F4? That is the formula. Before going to go through the kidney infection data, I have done some analysis also, simulation. So what is the kidney infection data? It has 38 patients. First and recurrence times are there, the first and second lifetimes 2. Okay, there is a gap between the first and second reference time. Okay, and the covariates involved are age of the patient, gender of the patient, and 3 types of diseases. These are in all 5. Okay, 8. These three diseases are GN, AN, PKD. Okay. All right. Now this is the model we used. 5 covariates, X4, X2, X3, X4, X5. And we are going to estimate the parameters, regression parameters, along with baseline parameters. Okay, before the data analysis, we have done some simulation study for the priority models. This is a priority model, the positive stable priority with generalized Rao. There is some printing mistake. This is a positive stable priority model. Generalized Rao-stick distribution, the true values and the estimates. Their estimates are close to true values that we can see here. Standard errors for this and lower credible intervals, upper credible intervals, GWK values, P values, and other things. This is for the model 1. This is for model 3. The true values, estimates, standard errors, and other things all are there. This simulation we are using to check the performance of the estimates, machine estimates. They perform well, that we can see from this table, the P values and the A values. Now, one more thing, I'm doing the goodness of fit test for the kidney infection for T1, T2. They fit well to the models we have suggested. And one can use these models for this data. Now go for the kidney infection data for model 1. That is this one. Estimates of different parameters involved, standard error, lower and upper, GWK, P values, and Gelman-Rubin values. When you see the theta is significant here, very high value, okay, 0.6. Beta 1, 2 is significant, we can see. Both lower and upper critical limits are negative. And beta 5, the third type of disease, okay, that is also significant. What we see here is beta 2 is the gender effect. That means females have lower risk of infection as compared to the male counterpart. The absence of third type of disease have a lower infection as compared to the presence of disease PKD. That is the meaning. This is similarly for the second model without priority. Beta 2 is again significant. All others are insignificant. That means females have lower risk of infection as compared to male counterpart. And model 3, that is a baseline model generalized viewable with positive stable priority. Beta 2, again, it is significant, and beta 5, third disease, type of disease. These two are significant. In all, most of the cases we see beta 2 is significant. Here also beta 2 is significant. All others are significant. That means in all 4 models we saw the females have a lower risk of infection as compared to male counterparts. And that is a now which model is better out of these 4 models? Model 1, 2, 3, 4, AIC, BIC, DIC is there. One is 622. Here 645, 624. This is the least value in all these 4 models.
5 minutes left only.
Okay, I'm going to please. Positive stable variety model 3, that is a baseline, is generalized viewable and share variety model of positive stable that has a least AIC, BIC, DIC, that is a better than all the 4 models. Compare also with our existing models. These are some existing models. This is also given by us only in earlier papers. And here also, if you compare with the earlier share variety models, this model is better than all other models. One can also see the base factors. In the base factor also, model 3 is better. Okay, this is a 6.3, and model 3 with 2, model 3. That means model 3 with all other 3 models, it is better. That we can see here. That is having a strong evidence against the model in the denominator. That is the base factor. That means from this also we can see model 3 is better. And I'm just comparing the AIC, BIC, DIC model with positive stable variety. I have some list of some positive stable variety models existing in the literature. If you compare there also, this one is least among all these previous models. That means whatever we proposed in this paper, that gives the better model, maybe best model as compared to all other previous models. That is the thing. And this is a fitting of the model with graphical fit. We also did the case statistic, p-values and other things, numerical fitting, and this is a graphical fitting. Here also it fits better. That is the thing. One can also have stochastic models also. Stochastic, some process, Z as a process. That make it, instead of Z, you can have ZT as a process. And we can introduce as gamma process, Weevil process, and other things as a variety model, and that can be. There are some papers also, some Levy's process and other things. We can also have semi-parametric models instead of parametric completely. We can have non-parametric distribution as a baseline, and we can also have that also. There are some papers based on the semi-parametric also. And one can also have correlated variety models. That I have some papers in the correlated that can be taken as a correlated variety models. Okay, I will stop here. I'm open to the questions. Happy to answer.
Yes, we have 1 or 2 questions time. If there is any query on the part of the audience, please, everyone is free to ask Professor David Enningal. Yes, Professor David Enningal, I have one question in mind. Okay. Can we consider variety models as a hazard model?
It's a hazard model. The only thing is heterogeneity involved in this. Yeah. There is a heterogeneity. We have introduced a random variable. Okay. In the hazard model. Right. The given hazard model, we introduce one more variable, that is heterogeneity, that is called variety.
Oh. Good. So if there is no other question, then let me thank our speaker, Professor David Enningal, for delivering nice talk. Thank you, Professor David Enningal.
Thank you.
Thank you very much.
Professor Malik.
Yeah. Thank you, please, sir. So now I quit because I have to join the next.
Okay, session. I have to chair the session.
Oh yes, good. That's why. So thank you, Professor Ladpatisa.
Thank you, sir.
Where are you?
I am in Pune, sir.
Okay, now I'm going to shift to another.
Okay, sir. Okay. I will look after.
Thank you, sir.
I will just leave and join another one. Just 1 moment.
Now, it is a great pleasure for me to introduce Professor Dr. Rao Sahib Ladpatisa, the chair of the session. Sir is an assistant professor from the Department of Statistics and Center for Advanced Studies from Pune University since July 1st, 2009. Sir Ladpatisa is mostly interested in sampling methods and also published many books like Advanced Sampling Methods, Spinger, and recent advances in applied statistics. Sir have also published many papers in journals, attended many conferences to inspire students with his knowledge, and work.
Hello. Hello, ma'am. Am I audible? Hello. Hello.
Hello. Good
Hi.
afternoon, professors.
Yes. Please go ahead. You are not audible.
Sorry, sir.
You are not audible now. Now continue.
Sir? Okay, sir. Thank you, sir. It is a great pleasure for me to introduce Professor Dr. Rao Sahib Ladpatisa, the Assistant Professor from Department of Statistics and Center for Advanced Studies from Pune University since July 1st, 2009. Sir is mostly interested in research studies like sampling methods and published many books like Advanced Sampling Methods, Spinger, and recent advances in applied statistics. Sir has also published many papers in journals, attended many conferences to inspire students with his knowledge, and worked as an expert at reputed Indian and foreign universities and organizations. Ladpati sir have also elected as an executive council member for the Indian Society for Probability and Statistics during 2020 to 2022. Sir have been the Vice Chancellor nominee for the Selection Committee of Assistants Professor and PhD students also. So, sir, I request you to chair the session and occupy the chair and conduct the contributory session in the stipulated time.
You are not audible, Ladpatisa sir. You are muted.
I request Dr. B.L. Bable to present his talk on strict and weak stationary time series model. Bable sir, are you there? B.L. Bable and D.D. Power, among them, anyone is there? If they are not there, then I request next speaker, Supriya, K. Supriya.
Yes, sir. Good afternoon, sir. Am I audible, sir?
Yes. Please go ahead.
Yes, sir. I'll first share the screen, sir.
Yeah. Right.
Just I'll share the screen. Sir, is my PPT visible, sir?
Yes.
Yeah. So good afternoon, everybody. So here I'm going to present a paper on a study. My paper is regarding time series forecasting models. So it is comparison of performances of the time series forecasting models, artificial neural networks, which happens to be a machine learning technique, and Arimax model, that is autoregressive integrated moving average model with exogenous variable, and hybrid model. This is a Arimax ANN hybrid model, which I had to use. This paper is a part of my PhD work. So I have to take up this hybrid model. I shall tell what are the situations, and I have compared the performances of these three models while the data was rice yield in Telangana state. Okay, so it is a well-known thing that rice is the most important staple food for more than 60 to 70% of the world population, and the nutritions of rice. And it is very proud that India ranks second in rice production in the world, whereas China stands first. So, and out of that, Telangana, in rice production in Telangana had shown a considerable increase for more than 20% during when it's compared to the last previous years. And it is accounting for 63% of food corporation in India and total paddy procurement. That is all fine, but still there is a limitation. So we are, as far as the exporting is concerned, Telangana's share in total rice export is only it is less compared to other states. So in this circumstances, I have studied on. So there are some challenges faced by the rice by exporters of rice. So in such situations, I made a study on forecasting the rice yield in Telangana using different time series forecasting models. So the time series forecasting models which I have taken into consideration are, first is artificial neural networks, which is a machine learning technique. And this is mostly used when the data shows a non-linear pattern. And autoregressive integrated moving average with exogenous variables. It is an improvement on ARIMA. ARIMA is autoregressive. We calculate the forecasted value based on the previous values of the same variable. Whereas in ARIMAX, we take into consideration the exogenous variables also. The exogenous variables which I have taken in this study are weather parameters, that is maximum temperature, minimum temperature, relative humidity, rainfall, sunshine hours, and also I have taken damage from pests also. So these are all the exogenous variables which I have taken while formulating this ARIMAX model. And the third is ARIMAX ANN hybrid model. I had to go for this hybrid model because the data, my data was showing both linear as well as non-linear pattern. So my study area is Telangana state. So Telangana, based on the agroclimatic situations, is divided as 3 zones: Northern Telangana zone, Southern Telangana, and Central Telangana. So I have taken data for 30 years, that is from 1990 to 2020. I have taken 31 years of data, and I have formulated this artificial neural networks. So artificial neural networks, as we all know, is a complex nonlinear model. When the data shows a nonlinear pattern, then here we have an input layer, then some hidden layers, and we have output. This was performed in using the software MATLAB. And then this is autoregressive. This first we'll see what is autoregressive integrated moving average. The ideology behind ARIMA model is again regression equation only, where we assume that the data more or less assumes a linear pattern. Okay, then these are the 3 parameters, P, D, Q, where P stands for autoregressive, Q stands for moving average, and D is the ordering and the differencing. Then ARIMAX model, it is an improvement wherein we consider the exogenous variables also influencing the rice yield. So now I discuss this model, ARIMAX ANN hybrid model. It is proposed by scientist Zhang in 2003. So this is a situation where the data exhibits both linear as well as non-linear pattern. Then we can go for this hybrid model, wherein the data is first analyzed using ARIMAX model. First step, where the linear component of the data is taken care of. Then we go for residuals. We calculate the residuals. And these residuals are initially, before we go for neural networks, analysis, we conduct a test, BDS test we call it, test of non-linearity, to confirm that the residuals are following non-linearity. So once the BDS test is satisfied, we analyze it using artificial neural network, and the forecasted value happens to be a sum of both linear and non-linear. This was proposed by Zhang in 2003. So this is the diagrammatic representation of the hybrid model, which I have just now told. Then I have compared the efficiencies, performance abilities, we can call them, using R square and root mean square error also. I have taken this too. I have also, in my thesis, I have also taken MAPE, max mean absolute percentage error, and other measures. But here I am discussing only 2 R square and RMSE. So when I have taken the data and I have compared, I have seen that I have forecasted it for 3 years. Actually, I have tried to forecast for more than 5 years. Then during Arimax, I have observed that when we are trying to forecast for many years, after a certain data points, the forecasted value is showing not much variation. And that means it is almost showing the same value, which I thought that this Arima and Arimax, these are short-term forecasting models. That is, we can use for 3 to 4 years, not more than that. So RMSE, I have calculated, I have compared the root mean square errors and found that the hybrid models RMSE was less, and R square was also, I have taken Karif and Rabi data separately and analyzed separately. So I have found that zone wise, Southern Telangana, Northern Telangana, all the 3 zones, it happened that R square value of hybrid model was highest, and sorry, RMSE, yes, R square value was highest and RMSE value was minimum for the hybrid model, which concluded that in all the 3 zones, when I forecasted the yield also, it was observed that the Northern Telangana zone had the maximum yield, and also prediction accuracies. When I was comparing, the hybrid model has outperformed the artificial neural networks and Arimax models, which indicated that the data of yield, which I have taken for the 30 years, had both linear and non-linear components. Thank you for the patience.
Yes, audience, anyone have any questions, they may ask. Hello. Yes, any questions anyone have? Okay, ma'am, you did hear the artificial neural network, right?
Yes, sir. Yes, sir.
You have whole set of samples. Among these one, few will firstly go for the test, and then later on the validity means some fraction is for the test and some for validation, right?
Yes, sir. 70 is to 30%, sir. Testing 70%, training 30%.
Training 30 and testing
70, sir.
70%. Okay.
Yes,
sir. Now in this case, you drawn some conclusions based on the MATLAB software, right?
Yes, sir.
Neural
networks I have performed in MATLAB, sir.
Okay.
But Arimax I have done in SPSS only.
SPSS you did.
Yes,
Okay,
sir.
okay. And this model you had used for the Zhang's model, right?
Yes, sir.
Well, ma'am, I am little bit wondered in which way you had contributed for this paper, entire paper?
Time series forecast.
No.
Sorry, sir.
Just try to understand my question.
Yes, sir. Yes.
Either while pursuing any kind of the research, either we have to propose the model, right?
Yes, sir.
Or sometimes using existing methodology, you have to come up with the novel applications.
Yes, sir.
right? Or vice versa.
Yes, sir.
In which context here you had work? Just let.
Whatever methodology is given, that was given in an industrial situation.
Okay.
So the same model, I have seen whether it can be applied. Actually, this is my thesis was regarding pest damage forecasting, sir.
Okay.
Major pest damage that is destroying the rice crop. So whether I could use in the same hybrid model in yellow stem borer, brown plant hopper, two major pests of Telangana, sir. I have used in that context, sir.
Okay. Okay, that's great.
Thank you.
Yeah. Yes. Next speaker, Panjala Maunikan.
Yes, sir.
Are you there?
Yes, sir. I'm in, sir.
I request you to present your talk on statistical analysis of air traffic of jet airways. Okay.
Okay, sir.
Please proceed.
Good afternoon, everyone. I'm P. Monica, research scholar in statistics in Department of Statistics, Usmania University, working under the supervision of Professor C. Jayalakshmi. Today, I'm going to talk about statistical analysis of air traffic of jet airways. So these are the contents of the paper, that is the introduction. Then we'll go through the materials and methods, and the analysis and the results, and we'll end up with the conclusion. Coming to the introduction, the aviation sector is a consistently growing and the most vital sector in the economic progress of a nation. The airline industry is one of the major service industries that considerably adds to the wealth of the developed and developing nations. So generally, this aviation sector is classified as domestic and international. Domestic air traffic will constitute 64%. And the international traffic constitutes 36%. There are a great number of studies, particularly since the 1990s, that use time series model forecasts for air passengers. So this study provides the forecast for air passengers on various time series forecasting models. That is, air transportation demand is highly linked to the economy. The data series will exhibit cyclic patterns and seasonality. So any economy is susceptible for a variety of shocks of difference in nature, which are likely to modify the volatility in the data. So the majority of the time series models we used in this study take both these characteristics into account, that is the trend and seasonality. So coming to the materials and methods, the source of the data is since this study is confined only to the number of passengers traveled to jet airways, we have collected the data from the DGCA New Delhi for the year 2009 to 2019 about the number of passengers traveled to jet airways. And the analysis is done for both the services separately. And in the analysis, we have considered 80% of the data for training, and the remaining 20% is used for testing data. And since the data in question is a univariate time series, only the forecasting models that are pertinent to univariate time series are exposed. So usually in the literature, we found that exponential smoothing and ARIMA models are beneficial for long-term and mid-term forecasting. So, but in our data, we have observed that there is seasonality, and seasonality is a complicating factor in time series forecasting. So hence, we considered the following models. So the first model we considered in this study is the Halls-Winter method, and a seasonal parameter can be added to the basic ARIMA model to account for this seasonality, which is a SARIMA model. And the selection of the best model is based on MSE criteria. Since it is scaleless, we have opted for MSE criteria to choose the best model. Also, another popular error criteria used for optimization is MAPE. And coming to the exponential models, there are three types of exponential models available in the literature. The first model makes use of two parameters, that is, which only take into consideration series and trend, whereas the Halls method, which involves three smoothing parameters, that is data, trend, and seasonal index. So as only the seasonal index is of concern in our data series, we have only used the Hall-Swinter method, which uses seasonal parameter. So coming to the Hall-Swinter exponential smoothing, it is a 3-parameter model, which is an extension of Hall's linear method. An additional equation will be added to this basic model, that is to constitute for the seasonal component. And this method considers the multiplicative as well as additive decomposition of the time series. And below we have explained both the models, that is the multiplicative decomposition and also the additive decomposition of the time series model. So these are the basic equations used in this Hall-Swinter's multiplicative model. The first equation constitutes for the series, whereas the equation which is represented by BT will constitute the trend estimate, and the equation represented by ST is a seasonal estimate, and the last equation is for the forecast for n periods ahead. And this is about the equations and the notations, where alpha is a smoothing constant for the series and beta is a smoothing constant for the trend, and gamma is a smoothing constant for seasonality. Under the additive decomposition of the series, we get the following equations. The differences, we take the difference of the terms. There we have taken the ratio of the term. The equations are quite similar, and we do the forecasting with the additive mode. And next set of models we have used is the ARIMA model. The ARIMA is an acronym which stands for Autoregressive Integrated Moving Average. In this, particularly autoregression means a model that uses the dependent relationship between an observation and the number of lagged observations. And is used for differencing of raw observations in order to make the time series stationary. And MA is a model that uses the dependency between an observation and a residual error from a moving average model applied to lagged observations. In general, ARIMA PDQ model is given by the following equation, where phi of B constitutes for AR and theta of B represents the moving average parameter. And one problem in the previous ARIMA model, that is the lack of symmetry, it is addressed by adding one seasonal parameter to the basic ARIMA model, which is called as the SARIMA model. So a seasonal SARIMA model is formed by including additional seasonal terms in the ARIMA model denoted by ARIMA PDQ and a capital PDQ with a seasonality parameter M, where M represents the number of observations per year. This seasonal part of the model consists of terms that are similar to non-seasonal components, but involves a backshift of the seasonal parameter. So once we have seen the different methods, we have started the analysis parts, and firstly we have applied the Hall-Swinter model for the test window. So as we have considered 80% of the data for our analysis and 20% is used for testing. So initially we have applied the Hall-Swinter additive and multiplicative model for both domestic and international data sets separately. So for the domestic data, we have seen that the additive model gives much lower AIC-BIC values. And for international data, the multiplicative model produces much lower AIC and BIC values. Having done that, we have also measured the errors. So as mentioned earlier, we have used MEPE and MASC for the error calculations. So here also we notice that the multiplicative model gives less error compared to the additive model in the domestic data set. And whereas for the international data set, additive model gives less error terms overall. These are the fitted models using the obtained parameters. So for the domestic model, we have fitted the multiplicative method, and for international, it is the additive model, which has given the lesser errors. Next, we have also checked for the SARIMA models, which is used for seasonal data. So we have used the same data set, and we have be run using the Serima model. So the domestic data which gave the Serima model as 100011, here 12 indicates the period of the seasonality. So with the AIC, BIC values. Also for the international data, the best Serima model obtained was Arima 100110 with the seasonality 12. Next, we have also calculated the error terms for both the domestic and international data sets of the Serima models. When we have compared these Serima results with the previously obtained Holt-Winther methods, we have noticed that Serima has outperformed both the models in domestic and international data set. So in both the data sets, Serima has given the lesser error values in both the international and domestic data set in both AIC, BIC squares and also the error terms. So having identified that Serima model is the best model for our data set, we have continued with the residual analysis. So this residual analysis is used to test the assumption of the normality of the white noise process. So here we have observed that for the domestic data set, the plots fluctuate around 0 and they are within the band about 0. So this means that it has a constant mean and variance, 0 mean and constant variance. Also in the autocorrelation graph, we can notice that the first lag is insignificant. It means that the residuals are independent, and also the histogram over the frequency curve represents the normal curve. So this implies that the domestic data residuals satisfy all the conditions of the normality. And also similarly, we have conducted the residual analysis for the international data set, that is the Serima model. And we have noticed that it has a 0 mean and constant variance, and the first lag is insignificant, and the graph represents the normal curve. And upon the completion of the manual forecast, for checking the model adequacy, we have forecasted the data for the next 12 months, and it is given in the following graphs. That is the forecast horizon. So this blue line indicates the forecast. We can notice that the forecast follows the trend of our data. Having done that, we have plotted the observed and forecasted values on the graph. Here we can notice that there is a good agreement with the observed and expected values of the number of passengers in both the domestic and international data set. With this, we can conclude that there is a reasonably good agreement between the forecasted and observed values for national and international data set. Hence, we conclude that Arima 100011 is the best model for forecasting domestic air traffic, whereas Arima 100110 is the best model to forecast the international air traffic. These are a few references for this paper. Thank you.
You are not audible, sir. You are muted.
Okay, students, do you have any questions? Hello.
I have a comment, not a question, basically,
Okay.
madam. Actually, on the same data set, you have applied both additive as well as multiplicative. I mean, you have checked additive and multiplicative decomposition, seasonal decomposition.
Yes.
How it is justified? Because either one will be applied, not both.
Because both constitute for seasonality, sir. Both are analyzed for seasonal data.
No, the data set, either it will be multiplicative or it will be additive. So I think before we analyze the data set, we should first investigate that which particular seasonality is there, and accordingly we choose the model.
Okay.
So that's what I was my comment.
Thank you, sir.
Thank you, sir.
Ma'am, I just want to put one question regarding the clarifications. You had choose two models, right?
Yes, sir.
Among these two models, you had fitted these two models for these two data sets.
Yes, sir.
And after fitting these two models, last question is, among these one, which model is the best? For this purpose, you employ the criteria. The criteria is the AIC and BIC.
Yes.
But for this criteria, AIC and BIC, which one is the most reliable, ma'am? And why?
Usually AIC criteria is based on parameters and the maximum likelihood, sir. And whereas the BIC criteria is used for the error terms. So we have considered both the criteria, sir.
That's fine, but which one is the best? Are you getting my question?
Yes, sir. Yes, sir.
Among these X and Y, whichever is the best. Then next question is why?
Yes. So actually for the time series analysis, we consider both the criterion, sir. Likewise, we have considered MASC and MAPE also.
Accept. But among these one, which one is the best? That is the question.
BIC is the best, sir.
BIC is why?
Because it considers the errors residuals also.
Okay. No. BIC is best, and why? We consider?
Because it is based on the basic concepts and the errors, sir.
Are you sure?
Yes, sir. It is because it is based on the Bayesian concept.
Okay. Okay, we'll stop here. And now the first student, as I had already called, is there Bable, sir? Bable? Hello? Hello, I got the chat in chat box. Recall 65 to the present. Who is 65? I think Bable sir is not there. Okay, that's fine. Then may I call the next candidate, Mrunmay?
Yes, sir. Yes, sir.
Mrunmay, I think it will be better. Just continue. And later on, we take the break for 5 minutes.
Okay, sir.
Just finish it in 10 minutes. Okay.
Sorry, is my PPT is visible, sir?
No.
Now?
No. Admin, I request you please. Yeah, right now it is visible.
Yeah, now it's visible.
Now it is visible.
So the title of the good afternoon, everyone. The title of my paper is a hybrid model combining VMD and TDWNN for time series forecasting. So as we know that a data set containing sequence of observations on a single phenomenon observed over a time is called time series data, and the most popularly and widely used time series model is autoregressive integrated moving average model. However, if our time series under consideration is nonlinear, then it goes beyond the capability of the ARIMA model. And to deal with these nonlinear patterns also, there are various statistical models are available in the literature, like bilinear, autoregressive conditional heteroscedastic model, ARCH model, GARCH model, threshold autoregressive model. But these models also have some specific assumptions and which are not always feasible to identify while dealing with the real world data, like for commodity price data, hydrological data, or financial data set. And as a result, the machine learning approaches nowadays has gained momentum, especially that artificial neural network approach and support vector machine for forecast for time series modeling and then rendering the nonlinear forecasting. So the main features or advantage of this approach is that it doesn't require the prior assumptions of the time series data that is under consideration, and it is heavily dependent on the pattern of the data, which is known as data-driven approach. And recent research activities that demonstrate that consolidating diverse models or approaches improves the exactness or accuracy of the forecasting when contrasted with the individual model. So similarly, there are one hybrid model is variational mode decompositions with a neural network. Time delay artificial neural net hybrid model is also one of the hybrid model which can improve the forecasting performance of the time series data. However, there are limited investigation regarding the choice of wavelet activation function for the neural network in the hybrid setup has been carried out to achieve the improved forecast performance. So with that motivation in this work, our focus was to develop a hybrid model, which is the combination of the variational mode decompositions and time delay wavelet neural network. In time delay wavelet neural network, the activation function that is employed, that is from the orthonormal wavelet family. And the advantage is that in traditional artificial neural network, generally sigmoid activation function has been employed. And the drawback is that in sigmoid that the problem or solution stuck into the local minimum. So we will not get the global optimum solution for if we use the sigmoid activation function. And this proposed approach VMD TD-WNN hybrid has been implemented in the two data set. One data set is monsoon rainfall data for Bankura district of West Bengal, as well as S&P for 500 daily data set of the stock market was considered, and the proposed model was also compared with the VMD TDNN as well as the VMD support vector regression model. So this is the outline of the wavelet neural network approach. The difference is that in case of neural network, we use the sigmoid activation functions, and here we have employed the wavelon or wavelet activation function. So there are various wavelet activation function. So here we considered the modelet wavelet activation function for this study. And this is the proposed forecasting framework. In original time series, the one condition is that if the considered time series is our non-stationary as well as non-linear, then it is better to transform the original into decompose into many. This is known as intensive mode function by employing the variational mode decomposition. So and the number of the k component has been decided by CFSA method, that is central frequency statistical analysis approach. The number of optimum k has been decided in this study, and for individual component we have utilized the time delay wavelet neural network model, and finally that we aggregated the forecast value by combining all the models. So this is the first data set we have considered, that annual precipitation data, month rainfall data for Bankura district for 1901 to 2018 were collected from the Indian Meteorological Department. And here the first 90% observations were used to develop the model, and while the last 10% data points were used for the validation purpose. So ADF test and PP test also confirm that the considered data is non-stationary, and this is the nonlinearity test also, and BDS test was employed to test the presence of nonlinearity data. So the data was nonlinear also. So this is the, after decomposing the series, this is the 10 decomposite series we obtained, and finally that the proposed model was compared with all the model VMD SVR, VMD TDNN, and as well as the individual model also, time delay wavelet neural network, support vector racing, TDNN, in terms of mean absolute percentage error and mean square error. So the model based on the MAP and MAC, it can be inferred that the proposed model VMD TD WNN outperformed than all the other competitive models, as well as if you observe that the difference between MAP and MAC in the training and testing data is also very less. So we can also conclude that the generalizing capability of the model is also better as compared to BMD TDNN. So because in case of BMD TDNN, it is observed that the training and there is a huge difference between the training and testing results. And also confirm the superiority of the model, we have also applied the Diable Merino test to confirm the statistical whether statistically this model is better or not. So the DM test also was significant, and we can confirm that this BMD TDWNN is outperformed than all the competitive other competitive models. And the second data set, we consider that Standards and Poor S&P 500 daily data series for the period of 1st April 2015 to 1st April 2021, and this is obtained from this link. And there are various features for the data, but in our study we consider the opening indices. And it is also known that stock market prediction is also very challenging due to presence of the volatility, nonlinearity, and chaotic pattern. So here also we divided the data in the same way, 90% for the first 90% for the training and last 10% for the testing. And we also applied the ADF test and PP test to confirm the that the data is stationary or non-stationary. The data was found that is non-stationary, and also nonlinearity test BDS was employed to check the nonlinearity pattern of the data. And finally, the same approach has been applied for this data, and for this data also similar pattern has been observed, means it is outperformed than the all the other competitive models, as well as that the generalizing capability of the model was also found good. And finally, to conclude, we can say that in theoretical and empirical research on time series modeling and forecasting is rapidly emerging, and the observed features of many temporal temporal time series data set constitute complex nonlinearity, asymmetry, and volatility. And often this type of prediction goes beyond the limit of the traditional artificial intelligence model or statistical model. So to deal with that, the hybrid models, hybrid models are increasing, becoming very popular. And with that objective, here also we have proposed one of the hybrid model, which is the combination of the BMD and time delay Weber-Newton models. So where it the idea is to differentiating the original series into different frequency component, and next integrating the prediction from the individual component. And it is also observed that use of wavelet based activation function and in neural network has offered a better outcome. And these are some selective references. Thank you.
Yeah, students, you have any questions? You may ask. Amrunmai.
Yes, sir.
Just I would like to ask one just clarification.
Yes, sir.
From your research. Here wavelet transformation you had used, right?
Oh, sir, wavelet activation function in the neural network.
Yeah. Wavelet
yes, sir.
activation. But in that black box, because of here, everything in the backend calculation are there, right?
Yes, sir. Yes, sir.
In the black box, actually,
Yeah.
what kind of transformation is there?
So actually, the conventional neural network use the sigmoid activation function.
Okay.
And here we have applied the wavelet activation function, and accordingly everything has changed. The estimation procedure, like in neural network, is
wait. For sigmoid activation function from -1 to 1, right?
Yes, sir.
We translate it in terms of smooth curve, right?
Yes, sir. Yes, sir.
And here what you are doing?
Yes, sir. Instead of sigmoid activation function, wavelet activation function has been used.
Okay.
And the range is same, but the functional form is different.
Okay.
And it has been observed that it can catch more the nonlinear pattern as compared to the sigmoid pattern.
Okay.
And other things in the like architecture point of view, and if you say estimation point of view, are considered same. Like estimation, we have used gradient descent backpropagation algorithm, and architecture is also the same MLP architecture.
Okay, thank you, Mrunmay. Instead of taking break, I think we'll enjoy our discussion and the continue lectures. The next one is the Ranjit Kumar Paul.
Yes, sir.
I request you to start your topic.
Yeah.
Deep learning technique for forecasting agriculture commodity prices.
Yes, sir. Just a minute. Is it visible, sir?
Yes, it is visible.
Yeah, just.
Yeah.
So, very good afternoon, Chairman of the session and other dignitaries. So, the title of the paper is Deep Learning Technique for Forecasting Agricultural Commodity Prices. Few of my previous speakers have already made my job easy by introducing the normal usual time series models which are in application. So basically in agriculture, when we go for empirical analysis of the agricultural series, particularly the commodity prices, they provide useful information which can be used by the policymakers and other stakeholders to formulate the appropriate policy to stabilize the price and predict the price for the future use. Now, in this regard, obviously, the Boggs-Jenkins pioneer work by proposing autoregressive integrated moving average methodology has been a dominated time series analysis for the last several decades. But just like any other parametric statistical model, this model is also based on some crucial assumptions of linearity and homoscedastic error variance, which makes it difficult in the reality to be applied for the series, particularly the agricultural price series, which are more volatile and they have some period of instability in practical data set. Now, the volatility forecasting is an integral part of the price analysis. In the last few decades, much effort has been devoted to the development of the forecasting model. The initial work was by Professor Angel in 1982 by proposing autoregressive conditional heteroscedastic model, followed by Buletslav in 1986 who proposed generalized arts model in modeling the volatility of a series. But the problem arises because it is not possible always to postulate the appropriate parametric form for the underlying phenomena, and in such cases we go for some non-parametric approaches. And among the non-parametric approaches, obviously the machine learning techniques have dominated recently. We also along with the stochastic model. Now, machine learning techniques which we know basically like artificial neural network, random forest, support vector regression, gradient boosting machine. There are lots of machine learning techniques which are being applied for forecasting the agricultural commodity prices. But there are some complex behavior of the agricultural prices which could not be captured by application of this technique, and then that's why this deep learning algorithm came into picture, which actually tries to refine the machine learning technique and increase the gain in accuracy of the forecasting. So here, under this, the long short-term memory model is one of the variant of the recurrent neural network, which can efficiently utilize the long and short-term memory information in a series. And unlike the other approaches, the main feature of it is that its feedback connection provides better understanding to develop the patterns of the series under consideration by implementing the back propagation of the current historical prices and the present prices. So the aim of the present study is to apply this deep learning technique in forecasting the vegetable market prices. Why you have chosen vegetable? Because it is a perishable in nature, and the price volatility or instability in the prices happens more frequently in reality. And the data we have considered for the analysis is the market price data of the cauliflower of 8 major markets in Odisha, which is one of the largest vegetable consuming state. The markets have been chosen based on the total arrival in the market. So that is the most important economic phenomena for choosing the major markets in a particular state for a particular commodity under consideration. The methodology which we have applied, the usual methodology of stochastic model like ADIMA, which has been discussed a lot in earlier. Then the machine learning technique dominated by obviously artificial neural network, one of the oldest, and then the deep learning technique, that is the long short-term memory model, which is a particular version of RNN or recurrent neural network. So we have the flow is as such that we have collected the daily data of the market price from Agriculture Marketing Network and also the Department of Consumer Affairs, Government of India. The daily data was converted to the weekly data. Then we normalize the data, because for application of the deep learning and machine learning technique, it is mandatory to normalize the data. Then we arrange the data in such a way that lags are can be used as the regressors in the model, because in the time series data, if we have the information collected on a particular variable, essentially over equally spaced time interval. So the regressors which are to be given as input in machine learning or deep learning or in stochastic model, that has to be in the form of the lags of the series. So accordingly, the data has been arranged, and that is splitting. Obviously, this is the most important step of model building. That data splitting has been done by splitting the data in 70-30. This ratio we have used, that is 70% for the training data and 30% for the testing. And then we have compared the performance measure for the above three models based on some well-known criteria. So this is the process basically. In ADIMA, you know, there is a basic prerequisite for application of this model, that is the ensuring the stationarity, and then go for identification of the parameters or the lags to be incorporated in the model, then estimating the parameters, diagnostic checking, and finally forecasting. In the NN architecture, which is the basic for the machine learning technique, there are three basic layers, which I think it is very much well known. In any of the textbook, it is available: input layer, hidden layer, and output layer. So in the input layer, we just give the input of the time series in terms of the lag, t-1, t-2. These are just denoting the first lag, second lag, third lag, likewise. And in hidden layer, there are activation functions to be called for to represent this data properly, and then in the output layer, we'll be getting the output. Now, this is the architecture for the deep learning technique, which is called, here it is LSTM, long short-term memory model. There are three gates, basically: for gate, input, and output gate. And the input gate is taking the input data in the name of xt, and then there is a combinations of this input with the bias and weights, and accordingly the cost function, and finally output we are getting. So these are the steps which are also available. The main thing or the salient feature of my study is this is the LSTM model, which is a kind of a deep, which is basically a deep learning technique. The application of deep learning technique is not that easy because of the complexity from the computational point of view. And basically the Python software is used for application of this kind of model. So what we tried is that we have tried to develop a R package for application of this particular model in reality, so that anybody and everybody can apply this model, but by just installing that R package available in CRAN already. We have published it, and that's the main feature, that we have just made this computation very easily, so that the deep learning technique in the name of LSTM can be applied in reality very easily. So these are the basically 5 steps for application of this deep learning technique. And the data set, now coming to the result, because from the theoretical perspective, we do not have any novelty to reveal. So I'm just keeping that theoretical perspective. And this is the price data. It looks like total 8 markets. You can see the clear seasonality. Obviously, the vegetable market prices are very much seasonal. In a particular month or in a particular week of a year, the price goes very high, and then in a particular month it goes low, and this feature continues over the years. So that's the seasonality, and it is clearly visible for all the 8 markets. Now this is the monthly average price. You can see that for this particular price, cauliflower, the price increase start at almost June, July. So June onwards, the price start increasing, and it goes beyond October or sometimes to November. And it is true for almost all the studied markets, which are major markets in Odisha. Now, these are the summary statistics, which are just to describe that If you see the kurtosis in some of the markets, it is high, and the variability in terms measured in terms of the coefficient of variation, it is highest in one of the market called Badgara, which is around more than 66%. Though in all other markets, it is more than 40. Now, this is the data structure which we have created, that by considering this time series and considering the lag, created this matrix, and this will be given as input in the data. So the user need not to do anything for preparing this data set, data structure. The user has to just call the univariate time series, univariate variable, which is a price data for a particular market over the years or over the month or over the week or over the day, whatever granularity of the data the user is fixing, that particular data is to be provided to this particular function, and everything else will be done automatically. Yeah, so this is the performance criteria for this model for these different 8 markets based on the RMSE and MAP. These are the most widely used validation criteria for comparing the efficiency of the model. MAP is percentage error kind of thing, and you can see in most of the cases, particularly perishable vegetable or volatile prices, we generally encountered the accuracy in a lower side. That means the error percentage will be in the upper side. So here also you can see that the usual ADIMA or ANN model, the percentage error goes even more than 50% in some cases in some markets. Whereas this application of the deep learning technique, if the training is done properly for a particular series, then it can reduce that percentage error, and it can increase the efficiency or accuracy of the market to a greater extent for all the markets. And these are the prediction. You can see the blue color shaded zone of this particular graph in the right hand side. This is the testing data, and left hand side, this is the training data. So prediction and actual is the dotted one, and the prediction is the smooth line, the red line, that is the prediction. So in almost all the markets, the prediction is quite satisfactorily, both in the training as well as testing phase. And this is the software package, R package, which has been developed, and it is available in the CRAN, so anyone can use it. To conclude, as the vegetable price, they varies quite a lot, and the price instability is very frequent in this particular prices. So prediction of this price is very difficult, and by using the usual models like a stochastic model like ARIMA or machine learning technique like ANN, it could not be captured the complexity present in the series, and that's why this deep learning technique has been used, and we have got some gains in this. And this significant accuracy, improvement in accuracy has been observed. Thank you, sir. Any comment, any question is welcome.
Okay, thank you. Yes, anyone wants to ask any question? Delegates? Sir, just one clarification I would like to ask.
Sir, sure.
In this LSTM, how much % of accuracy are getting increased?
So for this particular data set, it is more than 50%.
50%.
For example, in your usual ARIMA or ANN model, the percentage error was at the tune of 40% or so. So after using this deep learning, we got the percentage error reduced to 19 to 20%.
Okay, and in LSTM, you had given three kinds of gates: input, output, and forget. What is forget gate?
Forget gate is basically because from the name LSTM, this is long short-term memory. So in a signal, in a time series, we have 2 types of memory. One is a short memory, another is a long memory. The short memory is basically captured by the ARIMA model. ARIMA is a short-term memory model.
Yeah.
Now here, in case of the long short-term memory, in the forget gate, what happens that the current observation is based on the past observation. That means when the prediction is being done, then the immediate past observation is being taken into consideration. Now, along with that, the output is, we get the output at the first hand. Now, that output is again used for the computation of the prediction for the next t plus 1th instance. So that is basically being done in the forget.
No. Forget get.
So that's being done in the forget get.
Okay, thank you, sir.
Thank you, sir. Thank you very much.
Yes, Santosh Rathod.
Yes, sir. Yes. Good afternoon, sir.
I request Santosh Rathod to present his talk on a novel spatio-temporal time series approach for modeling and forecasting rice yield of Andhra Pradesh, India.
Sir,
Please go ahead.
Yes. Sir, my screen is visible, sir.
No, it is not visible. Yes, now it is visible.
Good afternoon, Chairman, sir, and the organizing committee and all the participants. Very good afternoon to all of you. The talk I chosen for this contribution session is the novel spatio-temporal time series approach for modeling and forecasting rice yield of Andhra Pradesh. And here in the presentation, I'm going to start with the introduction. Then what is the model which is mainly used in the spatio-temporal time series, that is Terma model. Then in the time series model, like spatio-temporal model, how we build the special weight matrix. Then what are the nonlinear components of spatio-temporal time series, and how this can be improved by using the artificial neural network and in the form of two-stage methodology. And this approach we have implemented in the this rice yield data. So we will conclude with some of the references. So as we know that the data set containing the sequence of observations on a single phenomena, we called it as a time series. But when we have a time series data over different locations of different space, so we call it as a spatio-temporal time series. A space-time models attempt to explain the systematic dependencies between the observations at various locations or spaces over the period of time. So the spatio-temporal time series has applications in different areas like geostatistics, sociology, agricultural, environment, ecological sciences, and all. And the CLIP and WORD were the first to attempt the spatio-temporal time series modeling in the time series framework. The space-time ARMA model that have less number of parameters compared to the VAR models. Even in case of VAR also, it is a multivariate time series models where you can use multiple inputs. So and the alternative of that is STARMA model. The space-time autoregressive integrated moving average model was first illustrated in a series of papers by Pfeffer and Weiss. In the autoregressive movie, it is same like ARIMA model. Only the difference is where we have the space and time lag. So this model, the ARIMA model, which is explained in the space and time, is called as a STARMA model. So the special information on different location is incorporated by considering the special weight grid. So the most commonly used special information matrix, the special weight grid is a uniform weight matrix where we assume that all the locations has the location or space has the equal contribution to the neighboring sites. So depending on special weight matrix is a key venture in building special weight matrix and in building a STARMA model where it determines the accuracy of the model. So this is the form of the STARMA model where the difference is we have W to the power L, that is our special weight matrix, and it is same as the ARIMA model, where we have both spatial and temporal lag. And as like ARIMA model, we have the same 5 steps model building stages. That is, first we see the spatio-temporal autocorrelation. The first criteria is if the locations or space under consideration are autocorrelated, spatially autocorrelated, then only we go for the spatio-temporal time series modeling. So second step is stationarity. Then for the identification, as like in ACF, PACF we use in ARIMA, here we use STACF and STPACF. And similarly, estimation and diagnostic checking are as similar as the ARIMA model. So as I said, in uniform special weight matrix is the most commonly used special weight matrix in STARMA model. If you see the I is my location of the interest, then the first color is my first order neighbors and the blue color is my second order neighbor. So we'll assign the equal weightage to the each location. Let us say for the ith location, if I have here and the 8th location, then I will assign the weight as 1/8. So this is in case of the uniform special weight matrix. And sometimes if I feel that the weights, the location under consideration, or they do not contribute equally, and they have different weightage to it, then we can go for the distance based on Euclidean distance, and by using this formula we can calculate the Dij, and the weight can be given as 1 by Dij. And in this study, what we have done, along with the this special the Euclidean distance special weight matrix, we have proposed we have used the KNN basis spatial correlate matrix. So by using the latitude and longitude of the locations, we have computed the nearest neighbors, and after determining the nearest neighbors, we calculate the correlation between the, for example, here we have used the rice yield data of the 13 districts of Andhra Pradesh, and that correlation has been directly given to as a weight matrix. Suppose, here I will explain the example. Here I have the 13 districts. In this 13 districts, based on the longitude, latitude, I have determined the nearest neighbors based on the KNN formula. So once the nearest neighbor is determined, I will calculate the correlation, simple linear correlation coefficient between these two districts, Srikakulam and Vijayanagaram. And the same thing, same weight like D1 and D2, will give the weightage as a 0.65 to those districts, and this will be incorporated in the model. So once the linear model is built, sometimes what happens due to the non-linear component present in the data set, sometimes the model may be composed of both linearity and non-linearity. So the demerit of the Sharma model is it identifies the pattern of the linear pattern only. So it fails to determine the pattern of the non-linearity. So that can be determined by using some artificial intelligence techniques like time delay neural network or some other machine learning techniques. So first, what we do is we see the assumptions of the residuals of the Sharma. If the residuals are significant, or if some autocorrelation is present, we'll check it by the means of multivariate box Pierce test. If they are significant, then those residuals will take it, and in the second stage, those residuals will be modeled by TDNN or some of the other machine learning like supported regression and so on. So this is the mixed nonlinearity in spatiotemporal, and as I said, to model the nonlinearity component, we'll use the time delay neural network. It is same as the artificial neural network, where we have our input lags as our inputs. And this is the about time delay, where we have three layers: input layer, output layer, hidden layer, and output layer. And the back propagation algorithm is used to calculate the error terms for the determining the weight in the second order derivative. And the most commonly used activation function is the logistic activation function. So this is the proposed two-stage Sharma methodology. In stage one, as I said, we first implement the Sharma model. If the Sharma model residuals were significant, then we just confirm it with the Box-Pierce test, and then whether the linearity is present or non-linearity is present in the residuals, we confirm it with the BDS test. Once the BDS test is significant, then we fit the residuals with the TDNN model, and the fitted values will be again added to the predicted values of the Sharma model, and then this will be compared. So this is the methodology of two-stage model, where for this illustration purpose, we have taken the yield of rice yield of 13 districts from 1991 to 1920. So this data has been collected from the DES Andhra Pradesh, and the data from 1991 to 2015-16 were used as a training data set, and the remaining 3 years data set has been used for the testing data set for the validation purpose. So to build the model, we started with the ARIMA model. So ARIMA has been built for the comparison for for each locations, we built the ARIMA model separately. Once ARIMA is built, then we implement the Sharma model. So in ARIMA, we got for each 13 districts, we got 13 models. But in case of Sharma model, we have only one model with these 4 parameters. So once you can see here, the residuals are for original series also autocorrelate, and the residuals are autocorrelate. It means there is some information left over in the residuals, and this information has this residuals has been confirmed as a non-linearity by means of the BDS test. Once it is confirmed, then these residuals were fitted using the TDNN model with the different weights given in this for each district. So the different weights has been identified, and the different model parameters, the TDNN has been built for the residuals. Once the residuals has been built, then as I said, in the residuals are added, the fitted residuals are added in the predicted values, and then the comparison were made. The comparison were made in terms of mean absolute percentage error, and here the three models were compared, and compared to the classical two models, the Sturmer 2 model, the Sturmer 2-stage model has been performed better as compared to both the remaining models. And the the MAP just tell us the observed difference between the actual values and the predicted values. So I have applied the divolt Merino test to see the significance comparison between the models. And if you see here, I have made the comparison between the Arima and Sturmer 2 and Sturmer and Sturmer 2. If you see here, the most of the cases, the Sturmer 2 is significantly different with respect to the both the models. So coming to the conclusion, when you have both linearity and non-linearity spatiotemporal time series, either the Sturmer model nor the your time delay neural network is going to work. When it has a mixture of both linearity and non-linearity in spatiotemporal series, so we have to go for the two-stage approach. And here in this example, the two-stage approach has performed better as compared to the univariate models. These are all some references. Thank you, sir. That's all from my side. If any questions, I will be happy to take.
Yes, delegates, do you have any question on it? Hello? Do you have any questions? Okay. Santosha, you had proposed this spatiotemporal model, right?
Yes, sir. Yes, sir.
And you had shown that one it is superior as
Yes,
compared to the Arima, right?
Yes, sir.
Yeah. In terms of their error component, but how much error? How much percentage of error reduction is there?
So here in this example, between 20 to 30%, as compared to Arima, it is more so, but as compared to the existing Sturmer model, it is 20 to 30%.
Okay, I mean it's two stages superior one.
Yes, sir. Yes, sir.
Okay. Okay. The next one is Suresh. Suresh or Srivallava?
Yes, sir. I'm there.
Who is presenting?
Srivallava, sir.
Okay. I request you to present on the topic effect of seasonal level shift outlier on the residuals of SAR1 and SMA1 models. Please go ahead.
Thank you, sir. Sir, is my screen visible?
Yeah, it is visible.
Okay, good afternoon. The title of my presentation is the effect of season level shift outlier on the residuals of SRA1 and SMA1 model. Myself, Srivallava, research scholar, and this is a joint work with my research guide, Suresh R, Assistant Professor, Department of Statistics, Bangalore University. And this is the outline of my presentation. That is, first I will give a brief introduction about the role of residuals in time series and the outliers in time series. Then I'll present the analytical derivation of the residuals of SRA1 and SMA1 model in the presence of season level shift outlier. Then it is followed by a simulation study and discussion and with my references. So this is the abstract which I had submitted. Then firstly, the role of residuals in time series in the paradigm of time series analysis. Initially, a tentative model is identified and parameters are estimated. Then the question remains whether the model is adequate. So it is at this stage that the residuals plays an important role. The analysis of residuals provides evidence for the adequacy of the model considered. An adequate model yields residuals which with the following properties, that is the residuals should behave like white noise, and the insignificant residual sample autocorrelation function for all lags greater than 1, and the residuals should be normally distributed with mean 0 and constant variance. Then the adequacy of the model is also confirmed by the by doing a formal test given by the Yelzeng and Box, which uses the residual autocorrelation, and even the iterative procedure given by Chen and Lee for the detection of outliers in time series uses the residuals as the starting point. And in addition to this, the estimation of the magnitude of an outlier also involves the residuals. So being aware of the importance of residuals, it is imperative to study its behavior in the presence of outliers. Next, outliers in time series. So aberrant observations are usually referred to as outliers in statistics. Intuitively, outliers are discrepant observations that look discordant from most observations in a data set. Time series observations may sometimes be affected by isolated events, disturbances, or errors that create spurious effects in the series and result in unusual patterns in the observations that are not consistent with the overall behavior of the time series. Such unusual observations may be referred to as outliers. They may be the result of unusual external events such as strikes, sudden political or economic changes, unusual weather events, sudden changes in the physical system, and so on, or simply due to some recording or gross error in measurement. So next, since there exist outliers in time series, we need to model them. So next, the formal definition and classification of outliers in time series context were first proposed by Fox in 1972, and there are more types of different types of outliers, which one can refer to, say, in 1988. So when outliers or structural changes are present, xt is disturbed and unobserved. In this case, it is assumed that the observed series yt follows the model yt is equal to f of t plus xt, where ft is a parametric function representing the exogenous disturbances of xt, such as outliers or structural changes. It is assumed that f of t is of the form f of t is equal to delta omega of b divided by delta of b into the ip of t, which is the indicator function signifying the occurrence of a outlier or the disturbance at time point t. And omega of b is equal to 1 by omega 1b minus so on minus omega s b into b power s, and delta of b is equal to 1 minus delta 1b minus so on minus delta r b power r are polynomials in b of degree s and r respectively. And delta is the constant denoting the magnitude or the impact of the outlier. Next, these are some review of literature concerning the effect of outliers on the time series methodology. The presence of an additive outlier, which is one of the type of outliers in time series, inflates the estimate of the error variance and hence of the process, which is studied by Suresh in his thesis. And the existence of outliers in the series has an effect on the sample autocorrelation function, which has been studied by Chan in 1995. And Chang, Tiao, and Chen in 1988 have shown that the existence of outliers seriously affects the estimation of parameters. This is the main focus of our presentation, that is the seasonal outliers in time series. In the analysis of time series, it is frequent to classify the perturbations or the outliers as 4 types of outliers, that is the additive outlier, level shift outlier, transient change outlier, and innovational outlier. When unobserved components, that is the trend, seasonal, and irregular components of the time series are considered, it is generally accepted that the additive outliers and the transient change outliers can be related with the outliers affecting the irregular component, and the level shift outliers can be associated with the trend cycle component, and the innovation outliers are the result of an outlier that simultaneously affects the trend cycle and the seasonal components. But when the time series with the clear seasonal behavior is considered, this classification may be too restrictive, since none of the 4 outlier types can describe a perturbation mostly related to the seasonal component. So Kaiser and Marvel in 2000 defined a seasonal level shift outlier which would affect the series as in yt, which is equal to 1 by 1 minus b power s into delta into the indicator function plus xt. And Kaiser and Marvel in their paper have found that the season level shift outlier are found in the European and Italian production index data. So the motivation for our present work is from Janvi and Suresh in 2011 have studied the effect of an additive outlier on the residuals of ARMA 1,1, AR1 and MA1 models. And Suresh in 2013 has analytically seen the effect of an additive outlier on the error variance. Then recently Askar and Uruj in 2017 have considered a modified season level shift outlier and have analyzed the performance of the test statistics in detecting the modified season level shift outlier by considering SAR1 and SMA1 model. So having known the importance of the residuals in time series, it is relevant, and with the motivation from all these three papers, it is relevant to study the effect of the season level shift outlier on the residuals. So let xt follow the general seasonal autoregressive moving average model of order P capital Q, Q and capital Q, and then the model is written in the equation 3, and where phi of B and phi of B is the autoregressive part, non-seasonal autoregressive part, and capital phi of B power S is the seasonal autoregressive part, and theta of B is the moving average part, non-seasonal moving average part, and theta of B power S is the seasonal moving average part, and AT is the white noise, and S is the seasonal frequency as the seasonal period. Further, all the polynomials are assumed is capital T is y is equal to x 1 by 1 minus e power s delta I into the indicator function, where y is the observed contaminated series, xt is the unobserved outlier free series, and delta denotes the magnitude of the seasonal level shift outlier, and it of t is an indicator variable such that it of t is equal to 1 if the small t is equal to capital T, that is the outlier occurs the time of occurrence of the season level shift outlier and 0 otherwise. Equations using 4, equation 5 can be written as equation yt is equal to the equation given in equation number 6. So so now coming to the seasonal auto, when the value of small p, small q and capital Q are equal to 0 and capital P is equal to 1 in the SARMA p comma q cross p comma q, we get the seasonal autoregressive moving autoregressive model of order 1, which is given by equation 7, where phi of b power s is 1 minus phi into b power s, and phi lies between 1 minus 1 to plus 1, assuming stationarity. Then the outlier model can be written using 6 as the equation 8. Let et hat be the residual series, which is given by et hat is equal to pi hat of b into yt, where pi hat of b is equal to it is given is in equation 10. So next, since pi hat of b is equal to phi hat of b power s, in the case of the SRA1 model, we get the residuals in the presence of the season level shift outlier using 8 and 8 in 9 as equation 11, and which is equal to at hat plus phi hat of b power s divided by 1 minus b power s delta into at of t. So let SL, the season level shift outlier, occur at time point t, capital T is equal to n by 2. That is at the middle of the series, where the sample size n is taken as k into s. That is, k is the number of years and s is the seasonal frequency. Then the residuals at time small t less than capital T, that is before the occurrence of the outlier, and t greater than or equal to capital T, that is after the occurrence of the outlier, which is given by et hat. Et hat is equal to at hat, which is before the occurrence of the outlier, and at hat plus phi hat of p power s divided by 1 delta to indicate function after occurrence of the outlier. Then expanding on the time for time greater than or equal to capital T, et hat can be expanded as plus phi hat of b power s divided 1 minus. So taking 1 minus b power s to the numerator, we get AT b power s is 1 minus p hat b power s plus 1 to the into delta. Then multiplying the indicator function to this term, we get the next equation.
Srivalabh, last 2 minutes. Hello.
Yes, sir. Sir, yes, sir.
Last 2 minutes. Please wind up.
So time part t, capital T, it is 1. So we get substitute for small t, we get capital T, we get this equation 14. And for t is equal to t plus 1, it is unaffected, and we get the equation. And in the same way for other points, that is after the next season, we can generalize in this form. That is time point t and as well as time points. Next is season order. YT and as equality. You to get the residuals in the presence of the outlier, taken in 9 as ET hat. Sir, am I audible? Sir, am I audible, sir?
Srivalabh, your time is over. That's fine. Thank you very much. Now I will call the
Okay, thank you, sir. Thank you.
Okay. I will call the next student, Tanjim Sheikh.
Yes, sir. Yes, sir.
I request you to present your talk on fuzzy inventory model for deteriorating items with selling price dependent demand and variable rate of deterioration.
Yes, sir.
Please go ahead.
So is my screen visible?
Yes, your screen is visible.
Okay. Good afternoon, sir. My name is Tanzim, and the name of my research article is Fuzzy Inventory Model for Deteriorating Items with Selling Price Dependent Demand and Variable Rate of Deterioration. So in this article, the objective was to develop a model considering demand dependent on selling price and deterioration which occurs after a certain period of time. Following 2-parameter Webel distributions, and shortages are not allowed. Fuzzy optimal solution is obtained by considering triangular fuzzy numbers, and for defuzzification, graded mean integration representation method, sign distance method, and centroid methods are used. Numerical examples are provided for the illustration of crisp and fuzzy, both the models. To observe the effect of change in parameters, sensitivity analysis are carried out. So basically, inventory is the resource that would help a small scale business to large industry or company to have a smooth and efficient management of stocks. Most of the commodities undergo deterioration over the period of time. Fruits, milk, vegetables, meat, medicine, etc. are examples of deteriorating items which does not start deteriorating instantaneously, but after a certain period of time, the deterioration of these items starts rapidly. So for the first time, the inventory model was developed by Harris in 1915, whereas inventory model for the deteriorating item was first studied by Within in 1957, and many researchers have done work in the field of inventory models. Inventory control is very important for both real life and research purpose. Theoretically, all parameters in inventory models are considered as certain, but in real life, it is not possible. In such situations, they are treated as fuzzy parameters. In 1965, Zadi developed a concept of fuzzy set, resulting in large number of research publications on inventory control as well as other fields using the fuzzy approach. These are the some of the research work done in the fuzzy inventory model. In current situation, climate change has already hit India as well as the world hard, causing huge social and financial losses in recent years. Unseasonal rain, cyclone caused major damage. It brought massive destruction to standing crops, which were ready for harvest in different areas of country. Hence, in the present model, selling price dependent demand is considered, which is useful in indicating the responsiveness of the demand of a certain deteriorating item to change in its selling price. The deteriorating item maintains the quality of quality for a certain period of time, and after that, deterioration occurs, which is considered to follow two-parameter Weibull distribution. Considering the scenario of real life, very few customers wait in the stockout period. Hence, shortages are not considered in this model. These are some of the notations that are used in this inventory model. And the assumptions are: single inventory cycle is considered, shortages are not allowed, the demand is assumed to be dependent on selling price of the product, which is given by alpha upon s raised to beta, and the lead time is assumed to be 0. For the model formulation, capital T is the length of the cycle. Initially, at T is equal to 0, the inventory level is capital Q, and it is assumed that there is no deterioration of the product in the time interval 0 to Tm. The deterioration starts at time Tm, and during Tm to capital T, inventory level decreases due to demand as well as the deterioration of the product. So representing this inventory model using the differential equations, we can see in equation number 1 and 2. And the solution for equation number 1 and 2 is given in equation number 4 and 5. The total cost of the model per unit time is given by the equation 1 upon T into purchase cost plus holding cost plus deterioration cost plus ordering cost. And these costs are represented in equation number 7, 8, 9, and 10. And combining all of them, the equation number 11 defines the total cost. For minimizing the total cost, value of T can be obtained by solving the differential equation with respect to T and equal to 0. And for the fuzzy model, these are the parameters that are considered as the triangular fuzzy numbers, and corresponding total cost under the fuzzy sense is given in equation number 12. Here, for defuzzification of the total cost, 3 methods are used, that is graded mean representation method, sign distance method, and centroid method. These are the formulas for those 3 methods, as well as for minimization of these, the total minimization of the total cost, value of T can be obtained by solving the differential equation again. Now, the numerical example illustrating the previous model, that is, if we consider for the CRIS model the following parametric values, then the solution for CRIS model is obtained as T is equal to 2.577213. Total cost for CRIS model is 193.8465, and capital Q, that is the quantity, is equal to 31.8039. On the similar basis, for fuzzy model, the result for graded mean representation method, we can see that the total cost is equal to 192.8763. That is, comparing to the CRIS model, the total cost has decreased. Similarly, The assigned distance method, total cost is equal to 192.390, and for centroid method, it is 191.9039. Then sensitivity analysis is also done for alpha and gamma. As the value increases, value of T decreases, whereas total cost and Q increases. Similarly for beta, as the value of beta increases, the T value increases, but total cost and quantity values decreases. For lambda, now as the value of lambda increases, T and quantity Q decreases, whereas total cost increases. And for Tm, as the value increases, capital T value increases, but total cost and quantity Q decreases. So the conclusion from this, the total cost is calculated for both crisp and fuzzy model. For the fuzzy inventory model, triangular fuzzy numbers are used. For defuzzification, graded mean integration representation method, sign distance method, and centroid methods are used. Comparing the result obtained from both crisp and fuzzy model, it can be concluded that fuzzy model gives more optimum value of total cost than the crisp model. Also, centroid method of the defuzzification method provides the minimum total cost. These are some of the references that were used. Thank you very much.
Yes, other delegates, do you want to ask any question? If not, Tanzim, I would like to ask one clarification.
Yes, sir.
As TM increases,
yes, sir.
Order quantity decreases.
Yes, sir.
I mean Q decreases.
Yes, sir.
Why?
Since the deterioration of the TM is considered to be the time when the product's deterioration starts. Since the deterioration is getting started, so the total cost, since they are deteriorating, we cannot give them for the same cost. That's why the total cost decreases, as well as the quantity is also decreasing, because since they are deteriorating, some of them might not be in the situation to be sold out. So that's why the quantity also decreases.
Sorry. What do you say? All are sold out.
No, sir.
Because of TM increases means what? Majority of them are just sold out, right?
Yes, sir.
Suppose my TM is equals to capital T, what will happen?
If TM is equal to capital T, that means that deterioration, there is no deterioration at all in the whole cycle.
Okay.
So they are in a good quality.
Okay, means all items will be sold out, right?
Yes, sir.
Okay, and again one more question.
Yes,
why fuzzy model gives us smaller cost as compared to the our crisp model?
Since for the crisp model, basically we are considering only one of the parameter, whereas for fuzzy model, since here I have considered triangular fuzzy numbers, there are 3 numbers, and it gives a more space for the calculation as well as for the uncertainty.
Okay, good. Yes, who is the next? Mohammad Nawaz. Are you there, Mohammad?
Yes, sir.
I request you to start your presentation based on Bayesian time series analysis of Nifty 50 and Nifty 500 index with RSTAN for Bayesian, ARMA and BSTS package.
Yes, sir. I'm audible, sir?
Yes, you are audible.
My screen is...
Yes, your screen is visible.
Okay, thank you, sir. Good evening, all.
But you are not visible.
Okay, sorry.
What am I saying? Your screen is visible, you are not visible.
Okay, now?
Yes.
Thank you. My topic is Bayesian time series analysis of 50/50 and Nifty 500 index with R stand for Bayesian, ARMA and BSTS package. In this study, we are considering the two models, Bayesian structural time series and Bayesian ARIMA models for forecast the time series. The Bayesian ARIMA model and the Bayesian structural time series model are compared in this paper with the help of the BSTS package and RStan for Bayesian ARIMA model. The BSTS model and Bayesian ARIMA model were used to pick the data, and we validate two models and predict the Nifty 50 and Nifty 500 index for the next 12 months. There are numerous studies dealing with the future pattern of Nifty index. However, these contributions have employed the conventional methods, such as classical ARIMA. Unfortunately, this model has certain limitations, such as the forecasts under ARIMA models depends on previous pattern of the series, along with the preceding forecasting errors. These models also encounter the issue of overfitting. As an alternative approach, Scott and Varian introduced the Bayesian structural time series in 2014. This model let the model parameters change over time, can handle large number of predictors and accurately reveal the stochastic behavior of the time series. In Bayesian structural time series, simply we can say decompose the time series into trend, seasonality plus regression. The spike and slab regression is used as a prior for variable selection, and after that we estimate the posterior distribution via Markov-Chain Monte Carlo method. Basic BSTS model is given is observation equation is yt is equal to mu t plus zt plus even t, and where mu t is the level, and mu t minus 1, mu t is equal to mu t minus 1 plus bt minus 1 plus e2t, and bt minus 1 is the random walk, where error terms e1t, e2t, and e3t follow normal distribution, and where zd is the regression beta into xt. Is the simple case without regression and trend. In the Bayesian model averaging, it is used to forecast our time series using BSTS. We simulate draws from the posterior using MCMC. MCMC sampling approach used to sample from the posterior distribution for the purpose of the inference. Make a forecast of YT using this estimate, can take average overall forecast for the final prediction. And our second model is ARIMA model. ARIMA model is AR and MA models. In AR model, series current values depend on its own previous values. For example, ARP model current value depends on its own P previous values. For moving average process, the current deviation from mean depends on its previous deviation. We are here considering the ARIMA models. To build an ARIMA model, we first check the stationarity, and if it is not stationary, we find determine the appropriate value of D and differencing, and after that we need to find the components such as P and Q. Basic ARIMA values such as ARIMA 202 and ARIMA 001, ARIMA 100, and ARIMA 101 are defined here. And using this, we are modeling with RStan. In Bayesian approach, the posterior distribution is directly proportional to likelihood and prior, and the likelihood function like y1, y2, etc. yn are independent observations of a random variable y. Then the likelihood function is equal to product I equal to 1 to n p of yi given theta, where n is the sample size. And the prior distribution theta explains what we know about the theta before looked at the data. The prior can be informative or weakly informative, this informative or uninformative prior. So in Stan is a probabilistic programming language for Bayesian modeling, and inference primarily uses the non-mutant sampler and adaptive form of Hamiltonian Monte Carlo algorithm. To make Bayesian analysis with Stan comparatively easier, we use the package RStan. Is a somewhat that uses MCMC. We apply here, our data is, we apply a real world financial data set of Nifty 50 and Nifty 500 monthly closing index from 2008 January 1 to 2021 December 1. We looked at the monthly closing price. It is a univariate time series. There are 168 observations. For our forecast accuracy validation purpose, we split the data into training set and test set. 75 and 25% ratio. In 75% of the data, that is 126 data points, and the test set contains 25%, that is 42 data points. And this is the basic RSTAN code for ARIMA 111. In RSTAN, there contain a data block and parameter block and model block. In data block, it defines the characteristics of data, and in parameter block, we are giving the characteristics of parameters, and in model block, we are define our model and the priors for the parameters. It is a basic ARIMA 111 model. And after the using STAN, we find the result for Nifty 500 for ARIMA 111 model. It is R hat, and R hat is 1, means the our model is convergent, and for ARIMA 212, similarly ARIMA 110 for Nifty 500 and Nifty 50 are given. After that, we validate our 3 models using leave one out cross validation. For Nifty 50, the low IC value is minimum for ARIMA 110, and for Nifty 500, the low IC value is minimum for ARIMA 111 model. And check the forecast accuracy for the 4 models that from we are using root mean square error as the measurement, and from here it is clear that BSTS model give very low root mean square error, which means the BSTS model based on structural time series model is best for the forecasting among the 4 models. So we are forecast the using BSTS for the next 12 months. According to the forecast, it says that the December 2022, the Nifty 50 price index will be on 19,455, and Nifty 500 price is in 17,397. And this is the forecasting graph, and this is our conclusion. In this study, we compare the 2 models with BSTS and ARIMA model. First, we fit Bayesian ARIMA model using RSTAN and calculate the U value to determine which of the 3 ARIMA models is best fit. All 3 ARIMA models U value differs slightly for Nifty 50 data. However, ARIMA 11 is best fit for Nifty 500 data. Then using root mean square error, we calculate the forecast accuracy of the 4 models. Because of BSTS model has the lowest root mean square error, we use it to predict the data. Thank you.
Yes, any questions from the audience? Nawaz, you had you had employed the MCMC process for while dealing with the Bayesian approach, right?
Yes, sir. Yes, sir.
Okay, for this MCMC procedure, you had presented one instance and shown that one. This
Sorry?
is my you had presented one instance of this in the context of MCMC.
Yes, sir.
You presented one instance and shown that one. These are my results, right?
Yes, sir.
Did you check its convergence of that MCMC?
Yeah, it is R hat is converges to R hat is almost approximate to 1.
No. For this MCMC algorithm, we have to check the MCMC through giving a test. That kind of tests are there. If convergence is not there, then it will be result may be correct, or may be misleading. That's why just look all of these issues. Hello?
Yes, sir.
Means whatever you did, suppose same thing I do, right?
Yeah.
I may not be met with this kind of results. Means it can be happen. That's why I am saying.
Okay.
Okay, thank you.
Yes, sir. Thank you.
The next student, Rajnind.
Rajni, sir. Yes, sir. Good evening, sir.
Yes.
Good evening, sir, and good evening, one and all.
Good evening. I request you please present the modeling of temperature using cupola analysis for Anandpur districts.
Sir, can you see the screen, sir?
Yes.
Good evening, one and all. This is A. Rajni. This is scholar from Osmania University. Today's my topic is modeling of temperature using cupola analysis for Anantapur district. And this is a work done under supervision of my supervisor, Professor C. Jayalakshmi from the Department of Statistics, Osmania University. And in today's presentation, we'll see introduction, methodology and the data, analysis of Anantapur district, conclusions, and future work. And coming to the introduction part, as we know, the temperature is a very key parameter in farming and in our day-to-day life. And coming to in farming, variety of vegetables, fruits, and pulses. Earlier, due to lesser understanding about forecasting of weather, farmers continued the work based on predictions. Wrong predictions in weather could lead to big loss. So the atmospheric conditions, temperature, air pressure, and moisturizer vary from one place to another on the globe. The temperature on the Earth normally ranges from -40 degrees centigrade to 50 degrees centigrade, and the global climate changes occur based on the amount of solar energy received by the Earth. Due to changes in the climate, it is very difficult to predict about the drought and heavy rains at any time in any corner. And an application is required to know the climatic changes depending on the place and time. Weather forecasts are important warnings as they help to protect life and wealth. Forecasted temperature and rainfall help in planning agriculture and trading of commodities. It is always better to forecast weather in smaller areas. This forecasting helps in deciding whether which crop has to be irrigated or not, should use fertilizers, and whether it is right time to complete harvesting, etc. It has been established in the literature of research studies that temperature and rainfall have a deep interdependency. Due to global warming and deforestation, we have been experiencing erratic rainfall. We are also experiencing higher temperature during rainy season and early summer. And coming to the review of literature, and there are a few literatures available based on the cupola analysis what I have done, and this is done mostly in various areas in the country. Coming to the India and especially in Telangana and Andhra region, this work has been done. So we picked this problem. So coming to the literature survey, Nelson Christopher de Zupai et al. In 2020, they provided modeling rainfall and the temperature processes using a Frank cupola from Archimedean family to derive a bivariate model and measure the dependency between them. And this work has done in Africa. And T. Mesbede et al. In 2019 found the structure of the interdependence of precipitation and the temperature in current and future under climate change conditions, which can assist in the risk assessment of extreme hydrological and meteorological events. And this work is done in Iran. And Ms. Tania Islam et al. In 2019 analyzed the involvement of bivariate correlation and linear regression. The result indicate that the Baristal district of Bangladesh, the correlation between rainfall and temperature revealed that rainfall is not dependent on the variability of the temperature. This work is done in Bangladesh. And Uttam P. Goswami in 2018 examined a cupola-based probabilistic behavior of precipitation extended over the eastern Himalayan region statistical downscaling model. And the cupolas are used for downscaling and the bivariate behavior of the precipitation extremes respectively. And this is done in Sikkim. And coming to the Georgia Lozoglu et al. In 2018 analyzed the temperature and the precipitation dependence among stations in the Mediterranean based on a new statistical technique in climatology, that is the cupola method. And this work is done in Athens. And P.K. Pandey et al. In 2018 observed that the interdependence between the mean temperature and the rainfall is more crucial in the context of the global warming and the climate changes because of the occurrence of the similar types of cupolas. And this work is done in Agartala and Bikaner. And Lin Fan et al. In 2019, they said that in cupolas were applied to analysis the probabilistic relationship between the monthly precipitation and the standardized precipitation evaporization index. And this work is done in China. And Milan Sisti et al. In 2015 addressed a different approach, that is joint analysis of the severity and the duration of the most demanding potential annual irrigation periods by bivariate cupola method. And this is done in Slovakia. This is a literature review. And next, coming to the methodology, why we have gone for this cupola analysis, we'll check it. And it is known that accurate analysis and the modeling of temperature and the precipitation process is a bit difficult due to the interdependence between them with multivariate technique as it is. In this direction, to develop a model considering the interdependency between the temperature and the precipitation, a special technique known as cupola analysis is available in literature of statistics. There are 5 cupola families which contain n number of bivariate distributions. So for a variety of applications, empirical data has shown that multivariate normal distribution is inadequate for several reasons. Some of them are when empirical marginal distributions are skewed and heavy-chained. And in contrast to the multivariate normal distributions, there is the possibility of extreme co-movements. And to overcome these limitations, we are using the cupola analysis. And the features of cupola analysis are the cupola contains all the information about the dependence between the random variables, and cupolas provide an alternative and often more useful representation of multivariate distribution functions compared to the traditional approaches such as multivariate normality. And most traditional representation of dependence are based on the linear correlation coefficient restricted to multivariate elliptical distributions, and cupola representations of dependence are free of such limitations. Cupolas provide greater modeling flexibility, and give a cupola, we can obtain many multivariate distributions by selecting different marginal distributions. Any multivariate distribution can serve as a cupola. A cupola is invariant under strictly increasing transformations. Most of the traditional measures of dependence are measures of pairwise dependence, and cupolas measure the dependence between all the random variables. This is a cupola analysis. This is a method. In the cupola analysis here, we have taken only 2 variables, that is the temperature and the precipitation. X represents the temperature and Y represents the precipitation. And first we find what are the marginal distributions of the temperature and the precipitation. Based on the marginal distributions, we'll find the joint probabilities distribution by using the cupola analysis. And the parameters are estimated by using the maximum likelihood estimation in the probability distributions. And to check the model adequacy, we are going for the best model. We have seen the AIC and the BIC values, and the best model is determined among the competing distributions based on the model's lowest archaic information criteria and the Bayesian information criterion values. Negative AIC and BIC indicates less information, less than a positive AIC and BIC. And model adequacy we checked based on the MAPE, mean absolute percentage error, root mean square error, and normalized root mean square error. And MAPE, it is a measure of determining how accurate a forecasting model is. It measures this accuracy as a percentage and can be calculated as the average absolute percent error for each time period minus actual values divided by the actual values. And coming to the RMSE, it is a standard deviation of the residuals. And in general, NRMSE, we'll go to the NRMSE, and in general, RMSE facilitate the comparison between the model to the same scales. NRMSE makes it scale-free. This measure, NRMSE, is a better indicator to assess the model performance, as the result performance of the model is comparable for simulating parameters with different units. And here, to establish the adequacy of the best fitted model distribution, we computed MAPE and NRMSE for each environment. Smaller is the value of MAPE and NRMSE and is adequacy of the model. Once the adequacy measures MAPE, RMSE and NRMSE are found very small, model is used for forecasting values of the testing period data to check whether the close agreement is established between the observed and the forecasted data. In general, values of the above measures are considered as smaller if they are less than 10%. For more efficient, we prefer to have them as less than 5% or around 5%. We collected the data, and coming to the data, and the data we collected from the Directorate of Economics and Statistics in Andhra Pradesh between 1963 and 2019. And from Indian Water Data Portal, we collected the data from 1901 to 1963. That is for the precipitation. And coming for the temperature, the data from 1901 to 2000 is collected from the Water Data Portal, and 2001 to 2019 is collected from the IMD and Telangana State Development Planning Society, Hyderabad for Andhra Pradesh. And coming to the analysis of the Anantapur district, Anantapur has a semi-arid climate with hot and dry condition for most of the year. And summer starts in the late February and peaks in the May with the average high temperature around 37 degrees centigrade range. Anantapur gets a pre-monsoon shower starting as early as March, mainly through northeastern winds blowing in from Kerala. And this is the data what we collected, and this is a mean temperature and the precipitation values in the month. What is the temperature in Anantapur district? It is a 22.876 and the precipitation is 1.047 millimeters. And February, it is a 25.162 and it is a 2.176 in a precipitation. And similarly, for all the months, the data is collected. And these are the mean temperature and the precipitation values. And coming to the correlation analysis, first, whatever the data collected for the temperature and the precipitation, we calculated the correlation between them. We used the Kendall's correlation and we checked its significance also. Wherever the significance is available, wherever the significance is finding, for that month, we have gone for the calculation of the probability distributions. And here, in the month of March, April, May, July, September, October, and December, we found the significance relationship between the temperature and the precipitation. And for the temperature and the precipitation where the significance exists, we calculated we found what are the component distributions, that is the marginal distribution. So in the month of March, we got the X Gaussian distribution for the temperature and gamma for the precipitation. In April, power exponential for the temperature and exponential for the precipitation. In May, normal for the temperature, Weibull 2 for the precipitation. And in July, normal for the temperature, X Gaussian for the precipitation. And September, reverse Gumbel. And in precipitation, Weibull. And in October, logistic and Weibull type 3. These are the component distributions for the temperature and the precipitation. And based on the component distributions, the fitted cupola distributions are, in the month of March, we got it rotated Clayton 270 degrees. And in month of April, rotated Gumbel 270 degrees. And in month of May, rotated Tron type 290 degrees. And in July, rotated Joe 270 degrees. September, rotated Tron type 1 270 degrees. October, rotated Gumbel 270 degrees. And these are the AIC, BIC, MAPE, RMSC, and NRMSC values. And here we can see that the NRMSC and RMSC values are less than 5%. That means whatever the model we fitted, this is an adequate model. And here we have got for the 80% of the data used for the testing, and 80% of the data is used for the training, and 20% of the data used for the testing. And here the blue line indicates that the training data, observed data, and the red color line indicates that is the calculated values. That are the estimated values of the temperature. So in the month of March, April, May, July, September, October, in all the months wherever the significance relation exists between the temperature and the precipitation, we estimated the values of the temperature by using the cupola distribution. So coming to the conclusions, after the complete analysis, we could draw the following conclusions. That is, using 80% of the collected data, initially we identified the best fitted probability distributions to the variables temperature and the precipitation separately, and these distributions in general are different for different months. Using the above identified best component distributions, we could identify the best fitted joint cupola model for predicting temperature for Anantapur district in Andhra Pradesh month-wise from April to October. As the climatic condition changes from month to month, the identified best cupola models are not same for all the months in Anantapur district. In order to establish the relation between the best fitted cupola, we computed AIC, BIC, MAPE, RMSC, and NRMSC for all the districts month-wise, wherever the relation is significant. It is observed that all the values of AIC and BIC are least. All the values of MAPE are less than 5%, and all the values of NRMSC less than or around 5%. This establishes the fitted models are adequate. As the fitted models are adequate, using them, we forecasted the values of the temperature for the time points in the testing data period. In this district, for all the months, wherever the models are fitted, we could find a close agreement between the observed and the forecasted testing data. Hence, it can be concluded that the identified best Coppola models can be used for prediction for future data points. As the fitted Coppola models are performing efficiently, this type of analysis can be done for all the other districts and states of the India, district-wise in each state. Along with temperature data on land, if bay, sea, ocean surface temperature data is also available, then appropriate analytical technique can be identified and used to measure the intensity of the global warming. If the data can be collected on precipitation and its associated variables, a similar Coppola technique can be used for predicting precipitation also. And this is our references. These all are the few references. Thank you, sir. With this, I end the presentation.
Yes, audience, do you want to ask any question? If not, then I will just ask one question to you. Suppose while modeling this kind of data, right?
Yes, sir.
And Coppola selection is wrong. What will happen?
Coppola selection, if it is wrong, means we cannot get the close agreement between the estimated and the observed values, and then we cannot go for the estimation of the future for the temperature, sir.
Okay. Okay, thank you, ma'am.
Thank you, sir. Thank you.
The next one is the Suresh.
Yes, Kalvinidhi, sir.
Suresh is not there. Then Sindhumol. Then who is?
Kalvinidhi, the presenter. Yes.
Kalvinidhi. Okay.
Yes, sir.
Kalvinidhi, I request you to start your presentation on predictive analysis on PM 2.5 emission using time series models.
Sure, sir.
Please go ahead.
A fine evening to all. This is Kalvinidhi, a project fellow, Department of Statistics, University of Madras.
No, wait.
Yes.
Okay. Is it your presentation, no? Yes.
Yes.
Okay. Yes, go ahead. Go ahead.
Yes, sir. So this research work titled Predictive Analysis on PM 2.5 emissions using the time series model is funded by RUSA 2.0. So I'll start with a fascinating fact that 9 out of 10 people worldwide lives in places where the air quality exceeds the World Health Organization's guidelines limit. So this fact is the driving force to carry out this research work. And yes. Oh, excuse me. Yes. So introduction, according to the World Health Organization, the air pollution is defined as the contamination of indoor or outdoor environment by any chemical, physical or biological agent that modifies the natural characteristics of the atmosphere. So the polluted air can cause critical problems in healthy people, including irritation on respiratory tracts or breathing difficulties during exercise or outdoor activities. So the actual risk of detrimental effects depends on one's state of health. So the role of PM 2.5 is crucial in increasing air pollution across major cities in India. It can be directly emitted from different sources and have a different chemical compositions. So the paper intends with a research focus of identifying a suitable predictive model to forecast PM 2.5 pollutant emission. So about the study area, in the event of health vulnerability due to PM 2.5 at Kodungayur, due to PM 2.5 emissions at Kodungayur in recent times, as evidently found and discussed by Masi Krishnan et al. During 2020, the major downside of the city, Chennai city, is considered as the steady area. So owing to the numerous small-scale industries The locality holds commuters from outside the area in a daily basis, which can cause more traffic congestion. So Kodungallur region has the substandard environment to breathe due to its high exposure to particulate matter of diameter less than 2.5 microns. So coming into the data description, the time series data on PM 2.5 emissions monitored at Kodungallur area is collected from Tamil Nadu Pollution Control Board. So the data is taken for the time period from 1st January 2019 to 31st December 2022. Sorry, 31st December 2021. That is the correction. So the data contains the variables date and PM 2.5 emissions with 1096 observations. So diving into the methods employed, the autoregressive integrated moving average model, known to be the traditional forecasting model, the generalized additive algorithm based profit developed by data science team of Facebook, and the deep learning based long short-term memory model, which is the special type of recurrent neural network, were the three methods implemented in the study. So the experimental results shows the feasible models for each forecasting methods were selected. So using ACF and the PACF plots, the tentative ARIMA model is of order 311 is selected. The whole data is trained using a profit model with the change point of range 0.8. And for the LSTM model, the LSTM model is implemented with the two LSTM layers known to be the input layers, one dropout layer and one dense layer, which is the output layer. So the recorded observations are predicted using the selected models, and the error rates were compared based on the root mean square error estimate. So the obtained data is forecasted using the model with the low error rates. So this figure 1 shows the line graph of PM 2.5 observed values versus predicted values computed through ARIMA 311 model. And the figure 2 shows the line graph of PM 2.5 observed value versus predicted values, which is predicted by a profit model. And figure 3 shows the line graph of PM 2.5 observed values versus the predicted values computed by LSTM model. So the table 1 shows the error rates of the models implemented. The root mean square or square error of ARIMA model is 4.33. The profit model is 11.17, and the LSTM model is 12.45. Yes, the table 2 shows the forecasted values of PM 2.5 pollutant using ARIMA 311 model. The forecasted value of can see there the bolded one 105.71 micrograms per cubic meter on 13th of January 22 clearly shows the higher emission of PM 2.5 pollutants, which is due to the Pongal celebrations, which is the harvesting festival of the state Tamil Nadu. So the findings shows the ARIMA model is the best predicting model for the obtained pollution data. So the forecast shows the first quarter of the 2022 will possess higher emissions of PM 2.5 pollution compared to the second quarter of 2022. Yes, from the research work, the result shows that the ARIMA model of order 311 turns out to be the well-suited model to predict the data with low error rates compared to the other models implemented in the study. The forecasting approach can help governing body to take remedial action against health emergencies and in mitigating air pollution problems. Yes, these are several references, and thanks for patient listening. That's all. Yes. Sir, I can't hear you, sir.
Hello, am I audible?
Yes, sir. Yes, sir.
Thank you, Kalunidhi,
Sure,
for presenting this topic. Now I call the next speaker, Jayashree.
Thank you, sir.
Jayashree.
Sir, good evening, sir.
Good evening.
Sir, am I audible, sir?
Okay, okay. Are you there? Okay, okay.
Yeah, yes, sir.
I request you to present your talk on the time series analysis on electricity consumption and its prediction.
Yes, sir. May I share the screen, sir?
Yeah.
Just a second, sir.
Okay, it is visible now.
Okay, sir.
Put it in the slideshow.
Yes.
Okay, go ahead.
Okay, sir. Good evening to one and all. This is Jayashree, research scholar, Osmania University, doing research work on time series analysis on electricity consumption and its prediction under the supervision of Raghavendra Sharma, sir, Department of Statistics, Osmania University. Here is the content: abstract, introduction, data and methods, results and discussions. Here the abstract. The main objective of the study is to fit a model to forecast the power consumption. Electricity is a vital part of modern life and important for the world economy. Electricity is now a supreme part of every sector. In this research study, the Box-Jenkins approach has been used to build the autoregressive integrated moving average model for the data. The analysis fits well with ARIMA 101, representing a good fit for the data sets. In this paper, were about forecasting the electricity consumption of Telangana using ARIMA model analyzed in order to find out significant information on power consumption and which allows us to predict the future demand with a certain degree of accuracy, which helps the requirement for future supply. So here is the introduction. India is the third largest producer of electricity in the world. India, along with the world, is facing energy crisis. India's power consumption grew by 4.5% in December to 110.34 billion units, according to Power Ministry data. In December 2020, consumption was 105.62 billion units, up from 101.08 billion units in December 2019. There is a significant gap in the demand and supply for electricity. Day by day, as our country progresses towards development, this gap is increasing, and tackling the situation is very important to continue our country's ascending path. In order to meet this situation, a number of options are being considered with a large focus on renewable energy research and development. The options considered are solar energy, biogas, wind energy, geothermal energy, to name a few. The development of the increased production of electrical power, which leads to the employment and the growth of the nation power energy capacity in Telangana. So according to the sector wise, the percentage it is divided into domestic 25.67%, commercial sector 8.31%, industrial sector 41.09%, and agriculture 17.52%. Thus, forecasting its consumption can be useful in better planning of its future. There is a need to carry out continuous research in forecasting power consumption so as to meet the need of increased population. This will enable policymakers plan ahead. As this need provokes the estimation of power supply, so proper analysis helps to build and promote their plans to execute and leads to an economic growth. For proper policy making, we allied the problem for the analysis of power consumption and develop a model for forecast. The goal of the present problem is to develop a precise mathematical model that helps in forecasting power consumption values of the observations, primarily based on the characteristics of the record. The time series technique is one of the effective statistical methods for predicting future values. So in order to make the time series stationary, if the data is not stationary, then it can often make stationary by differencing it. Autoregressive integrated moving average is a generalization of an autoregressive moving average. Model introduced by Box and Jenkins are applied when data shows evidence of non-stationary. The accuracy and flexibility for forecasting the univariate time series models, the identity of a suitable mathematical model, parameter estimation, and predicting future values are frequently provided by means of ARIMA models. In this paper, the extensive process of constructing ARIMA PTQ models for the future as a conception of the electricity provide power sectors to plan future decisions. Here, this is a models, autoregressive model. Thus, an autoregressive model of order P can be written as, this is a mathematical model, yt equal to c plus pi 1 by t minus 1 plus pi 2 yt minus 2 plus 1 plus pi p yt minus p plus epsilon t, which gives lags of yt, and we refer it as AR of a P model. And here under the moving averages, here we'll take the mathematical model as yt equal to c plus epsilon t plus theta 1 epsilon t minus 1 plus so on theta q epsilon t minus q, and here it gives a moving average model of order q, where each value of a yt can be of a weighted moving average of the past few forecast errors. A moving average model is used for forecasting future values, while moving average smoothing is used for estimating the trend cycle of past values. Combinedly, we will be writing the autoregressive and the moving average as this mathematical model, that is yt prime equal to c plus pi 1, that is yt minus 1 prime plus so on plus pi p y prime t minus p plus theta 1 epsilon t minus 1 plus so on theta q epsilon suffix t minus q plus epsilon t. And here epsilon prime t is the difference series, and the predictors on the right hand side include both lagged values of yt and lagged errors as well. So we call them this as an ARIMA PDQ model, where P is order of the autoregressive part, and T is a degree of a first differencing involved, and Q is order of moving average part. So this is a flowchart that we have followed. First, plotting the data, identifying whether the data, and if necessary, use a box transformation, stabilize the variance. If it is, if we select the model order, here it is used. That is, if necessary, difference the data until it appears stationary. Use unit root test if you are unsure. And here ACF and autocorrelation and partial autocorrelation values also, functions also it is applied. And after that, even AIC model is built for the better to identify the better model predictions. And here it goes on, checks the residuals, ACF, and then it goes once if it is a stationary, and once we find the best fit model, then we'll have an accuracy to obtain the accuracy of the forecast model. Or else, if it is stationary itself, we can directly go for the ARIMA model. Next, here is the data and the methodology. Here the data, it is a secondary data set that is a 503 data points over 2 years, 92 is obtained. The data sets is taken. That is the area of Telangana, and this data sets analyzed by using Python, and here ACF and autocorrelation and partial autocorrelation functions also here it is applied, and AR and MA values, ARIMA model, it is fitted for the given data set. And here the model identification we had. Here the hypothesis H0 when it is not a stationary, H1 when it is a stationary. As according to our analysis, Dekefula test, we are getting a 5.860 and P value 0. Since P is less than 0.05, therefore we reject the null hypothesis. So we can say that the data is a stationary here. And here are some of the, after repeating the autocorrelation and partial autocorrelation, here these are the lags we have obtained after analyzing. And here, after building the model for different parameters, the best model here we find here is 101. So for 101, for AIC 101, the best model fit we have found to get our accurate predictive predictions. So this is a AIC value, that is 4,269.073. And these are the parameters, parameter coefficients we have obtained: autoregressive, constant, and moving average, standard deviations, and Z values. So these are the values that we have obtained. And here we find the L-Jung box value and probability value, and the values accordingly which we have analyzed and we have obtained the statistics. We can say the diagnostic check. By the diagnostic check, we can say for this model, the value, the p-value, which is 0.85 for the L-Jung box statistics, is greater than 0.05. So which indicates that the process is white noise. So these are the forecasted values that we have obtained after analyzing. So for conclusion, this exploratory study provides a thorough time series analysis of the power consumption data by considering the box and the Jenkins modeling with a specific ARIMA model building and prediction. Also, this study authenticates that ARIMA 101 is the most appropriate and effective model for accuracy in prediction and with the best parameter estimation. The study of the model building helps the power sectors to plan for future demand. So these are some of the references. Thank you.
Okay, thank you, ma'am.
Thank you, ma'am, sir.
I request the next speaker, Chetan. Are you there? Chetan? Am I audible, sir? Balkrishna, sir?
Yeah, you are very much audible.
Okay.
Why there are some absentees?
Yeah, some absentees are there.
Yeah.
Okay, lastly, I will put the last word on this one. I am very much thankful for the organizers for giving me an opportunity as a chairman for the time series session, in which some majority of presentations are very nice one, nice applications are there, and nice approach for predicting the models. Majority of speakers had presented. I am thankful to you, to one and all. Thank you. Over to you, organizers.
Thanks to the chair, Professor Ladpatisa.
Thank you, sir.
Thank you, Dr. Ladpatisa, for chairing this session, and all the presenters for sharing your valuable knowledge with all of us and sparing your valuable time. Thank you, everyone, for making today's session successful.
Okay, see you. Bye.